Hari, just keep checking parallelly.
Yeah. Yeah, we are live.
Okay.
We are live. We are live.
Amritanshu, you can start. Yeah.
So, good afternoon, India. This is Amritanshu Vajpayee, and as usual, I welcome you all to this 4 day, to the final day of this 4 day quadrennial webinar education series under the leadership of Indian Space Industries Exhibitors and its knowledge partners. As we all know, we have been celebrating the National Technology Day 2021 under the ongoing COVID pandemic through the virtual mode with this exciting webinar series on advanced technologies and applications in engineering for the last 3 days. And today, yes, we have come to the concluding day of this exciting set of events in which you all may have heard people from different streams from different reputed institutions, academia, as well as the industries. So, going on to the same note, progressing from the first day when we had discussed in detail about the 3D technologies. Next day, on the day 2, on 12th, we went on to see the applications like smart materials and inflatable structures. And yesterday, in fact, on 13th, we went into the details with the innovations in the advanced manufacturing technologies and polymer composites. So today, the time has come for us. It's the right time to dive deep into another exciting field of prospects with the esteemed speakers for the day who have already joined us. And on behalf of all the participating institutions, the knowledge partners, and the organizing institution ISIE, I welcome the speakers of the day, Mr. Santosh Hulaule, the CEO, Indra Robotech Private Limited, Mumbai, who shall be taking us to the field of role of robotics and automation in the growth of various sectors in India with his practical demonstrations also. So tighten up your seat belt. It is going to be a very exciting demonstration as well as an online session. That will be followed by a very, very exciting lecture from Dr. S.R. Chakraborty on flying taxis development in India, who is currently a professor of aerospace engineering at IIT Madras. And the concluding session, again, yet another exciting prospect will be smart drone applications by Dr. Dharmendra Singh, professor electronics and communication from IIT Roorkee. That shall be followed by a discussion where we will be joined by the academia as well as the representatives from the industries and the organizers under the leadership of Dr. AC Mathur. Now, with these words, I just hand over the reins to Sri Chintamani Pai, the knowledge partner of Space Geeks India, to introduce the first speaker of the day. And before Chintamani Pai sir takes control of the entire session and begins this convenership, I just would like to request welcoming all the honorable participants to the meet who are joining and who will be joining, and also on the YouTube forum, that if under the course of the talk of the honorable speaker, you find any of the queries pointing towards the any queries that are relevant towards the talk of the speaker of the day, you just type your queries into the chat box or into the inner chat box of the internal meeting. They shall be taken up by our technical meeting towards our speaker of the day, and we shall try to resolve at maximum permitting the time. So with these words, welcoming all, I hand over the reins to Chintamani Pai sir from Space Geeks. Welcome Chintamani sir, welcome speaker sir, welcome all the participants. Over to you. Chintamani sir, please unmute yourself.
Yeah. So sorry, there was some internet issue at my end. Yeah. So good afternoon, everyone, and uh, we are at the fourth day of our ongoing awareness webinar series, and every day my excitement level, went on increasing, and today we are at the pinnacle of that excitement, and while we are at the pinnacle and we have this excitement session, it is my pleasure to introduce today's speaker. But then I have my team member who will be officially introducing our today's session speaker. Hari, over to you.
Oh, hi, good afternoon. Am I audible?
Yes, Hari, go ahead.
All right. Okay. Myself, Hari Tejas from Space Geeks. We have the pleasure of introducing Mr. Santosh Vasudev Gulable, who's the founder and CEO of Indro Robotic Private Limited. Well, after completing his engineering degree, he has been involved in the field of robotics for the last 20 years, first by himself in his own custom-built laboratories. His research of the past 2 decades has borne fruit in the form of fully functional prototypes and other products. And if I'm correct in saying, more than 18 fully functional life-sized humanoids have been built. Recently, in October 2020, Mr. Gulable incorporated his company, Indro Robotic Private Limited, and has a very capable team of engineers and other skilled workers um, in his company. His company is located in a Mumbai suburb, Gokuldam, which is located in Goregaon East. His latest project was the development of AI-enabled, artificial intelligence-enabled humanoid robot, Indro 3.0, and further plans include development of service robots to cater to a wide variety of other purposes. His customer base includes companies like Tech Mahindra, amongst other groups. While preparing this short introduction, I came across one of the quotes that was associated with his company. If you want people to believe your ideas, they have to be first manifested into reality. And just reading about his efforts for 2 decades, like working on a zone and then finally developing it into a company, it's quite inspirational. And I hand over the dais to him so that he can speak more about himself and his company. Welcome, Mr. Santosh. Please take over from here.
Thank you so much. I would thank you everyone first of all for the today celebration. The robotics and automation in the group various names. Since today is a very auspicious day, I would also a very happy Akshaya Tritiya and a very happy Eid. So before I start topic, I will to my company, Indro Robotic Lab. As a company is all about manifesting ideas into reality. And these are that have been manifest reality. After being 20 years, last
Santosh,
2-3 years,
sorry to interrupt you. I think there is some network issue from your end.
Yeah.
So we are not getting a continuous stream of video.
Both your video and audio are affected.
Yeah, it is showing.
Is it breaking?
Yeah,
okay.
yeah.
Okay. I'll just see. One second. Wi-Fi seems to be okay. One second. I'll do one thing. I'll just put it on my data. I'll just. Hello. Hello.
Hello.
Hello. You can hear me now? Is it audible?
Yeah. Still, there is some lag. In
the video. Just give me a second. I'll just see whether I have any other equipment.
Yeah.
Active.
Yeah.
Wi-Fi is the band kar Wi-Fi is on. No other equipment are on. Yeah, just check if there's any. Just one second. I'll just put on the Wi-Fi again. Give me a second. Oh.
So, dear friends, thanks for your continuous support over the course of last 4 days. And as the current situation is, our first speaker of the day was just experiencing a little bit of difficulties with his connectivity. So he is just mending up his connectivity from his own end, and he shall just be joining us all again within a time span of a minute or so. So I just request all of you to be a little patient and remain with us. The session, I assure you on behalf of ISI, that it's going to be very, very exciting session. So I just would request you to kindly stay with us. And as I can see, our honorable speaker, Santosh sir, has joined us again. So I hand over the reins to Santosh sir. Over to you, sir.
Hello. Uh, am I audible now? How's the
Yes.
video?
Yes, Santosh.
It's okay. Seems okay now. It's
Yeah.
okay? Okay. So just before I start talking about the topic, I would like to throw some more light on the actual base of the topic, that is the robotics and automation. So you need to understand first what is robotics and automation, and why India is still lagging behind in accepting robotics and automation. So starting from we'll look at the country like China. I mean, the demographics of China and India are almost same, but the way they have become the manufacturing hub of the world is only because of the robotics and the way they have adapted robotics and automation. We have to look at it in a similar way. Most of the time, people ask me that India is already an overpopulated country. I know what robots are going to do here. Hello, am I audible? Hello.
Yes,
Hello.
you're audible.
Yes,
You're
sir.
audible. Okay.
Yeah.
So most of the people, they ask me the question that why do we need robots in India, which is already an overpopulated country? What are robots going to do here? See, if you have the same mentality and attitude, we are never going to be able to compete with the international market, because the way the world is progressing with the help of robotics and automation, we need to change the traditional methods of manufacturing. The good part is that the robots that used to cost like a crore rupee a few years back, they have come down to a few lakh rupees now. So that's the advantage. So before, the robots were only being used in the large scale industry. Now even the small scale and the medium scale industries, you can see the use of robots there. So this is going to be a game changer. And not only in the industrial sector, automation and robotics are going to be contributing in almost every sector of India, be it the healthcare center, be it the construction companies, be it the civil industry. So almost every, the defense, security. So instead of talking about that, I will give you a live demonstration, because I know you would like to see what exactly robotics can do. I will give you a live demonstration of two of my robots, what exactly they can do. So you'll get an idea of what automation can make happen. Okay, are you ready, guys? So what you're seeing on my right side here, this is MSR, which is called as multiple service robot. So this robot is specifically developed for multiple service tasks. It's based on predetermined artificial intelligence. So of course, all of you people must have heard about artificial intelligence. So there are many aspects of artificial intelligence, starting from machine learning, deep learning, and neural network. So the machine learning part, predetermined learning comes in the machine learning part. So I'll show you how the robot has been programmed to perform a predetermined task and how it is capable of performing it. So see how it does it. Try to stay away from the camera so you'll get a full view of the robot. So basically what this robot is going to do is it's going to come here, pick up a bottle which is kept here. As you can see, it will get hold of the bottle. It's going to pick the bottle and it's going to serve. Now it's making a sign that I'm supposed to receive the bottle. Comes towards me. I catch hold of the bottle. See, it has served the bottle to me. I keep it here. And it will go back to the homing position. Now what it's going to do is it's going to go all the way up here on the second tray, and it's going to get hold of this bottle and it's going to serve me. This time it's going to serve the bottle on the table. See how it does. It's coming all the way to the second tray. I hope the video is clear. Hello? Hello?
Yes, video is clear.
Okay, sounds good. So it's going to get hold of the second bottle here now. This time it's going to serve the bottle on a table. Let's imagine there is a table here. It's going to come forward. This time it's going to serve the bottle on a table. Here, just serve the bottle. Now again, it will go back to the homing position. And all what you're seeing here is all happening by itself. This is what you call as predetermined learning. And it's happening with a less than 1 millimeter of precision. That's how precise the robot is. Again, it goes back to the homing position. Now imagine I have finished this drink and the robot is supposed to collect the drink from me. See how it does it. This time the robot will come directly towards me. It will make a sign that I'm supposed to hand over the bottle to the robot. So I'll hand over the bottle to the robot. It will get hold of it. It's got hold of the bottle. And now it's going to keep the bottle in the tray. Now the robot is going to perform some maneuvers with its rover. The rover, what you're seeing here, it's a fully autonomous rover. You don't have to control it. You simply have to program it. So the robot can guide itself through a very predetermined path, exactly how it is programmed to. See. That's the to and fro movement. We can adjust the speed of the robot. We can increase it, decrease it. Now it's turning itself. You see how it can turn itself? This particular robot, MSR S1, it's based on an industrial structure. This robot can function 24/7, 24 hours a day, 365 days a year, without any malfunction, without any major breakdown or servicing needed. That's how it is built. So I'm giving you a practical example of robotics, what it is capable of doing. And you'll be very excited to know that this robot is built right here in India with the resources available in India itself. 95% of the robot's volume, it's been built right from scratch here itself in India. So the kind of mentality we had that we cannot build robots in India, we need to forget it. We can do it right here in India. I'll show you how precise the rover is. Now see, the rover is going to come all the way here and it's going to stop here. Okay, looks like we're done with the programming. I'll show you the other robot now. So as you can see on my left side, hello, am I still on? Hello, hello.
Yes, sir. You are audible.
Yeah. Just keep beeping so I know that somebody's there. So what you saw was a service robot. So what's the difference between a service robot and an industrial robot is the robots are being categorized by the number of axes they have. When I say number of axes means number of joints, or you also call it as degrees of freedom. You get it? So what you're seeing here on the right side, this robot has got 8 direct axes and 2 indirect axes. So these are 2 indirect axes and these are 8 direct axes. So it's a 10 axis it's a 10 axis service robot. What you're seeing on my left side, it's a 10 axis humanoid robot. Why a humanoid robot? Because it's been built like a human. You get it? Both these robots are built for completely different nature of work. I'll show you what the humanoid robot is capable of doing. Here we go. So it's on. What the robot is going to do now is it's going to first do a shake hand. See how it does it. This thumb here is doing a shake hand with me. I hope you can see me. So it's going to again do a shake hand. This time it's going to be a much faster shake hand. You see, I don't touch it. See, it's much faster. You see. Now it's going to look around. So all the 10 axes you can see they are functioning at a time. There's a microcomputer in the robot which is controlling all the actions precisely. Now you see it's moving its head. Now it's moving the head very slowly. It will move it faster now. So we can vary the speed of the robot. It will do a yes action. It's doing a yes action. It will do it faster once again. Now it's going to do a high five, I guess. See? It's going to come here as a high five. I hope you saw it. We'll do it once again. That was a high five. Now the robot is going to do some next maneuvers. This robot can also bend forwards. I would like to tell you this is one of the only humanoid robots built in India which can actually bend and twist its back. Now it's going to try to perform a small dance maneuver, I guess. Nobody's controlling the robot. It's doing it all by itself. It's predetermined learning. Now I guess it has done all the actions and it is going to do a bye-bye. Saying a bye-bye now. So you guys saw it? Hello? Hello?
Yes,
Hello?
we saw it. It was working nicely.
So that was a live example, actual example of what robotics can do. So that's what I'm trying to tell, that just imagine if you harness this power and we use it for the development of our country. So it's like the the thing here is, a few years back, 50 years back, when the machine era came, everybody was talking the same thing, that the machines have come, now the jobs are going to go away, people are going to lose their jobs. But it didn't happen that way. Of course, in the initial stage, some people did lose their jobs, but it created a different kind of jobs. Similarly, same thing is going to happen again with robots coming in. People might lose a few jobs, but then we'll have newer jobs. We have to look at a culture where we and robots work together and contribute to a better society. We have to look at China, how they are producing. They've become a world manufacturing hub, international manufacturing hub. Similarly, we have to do the same thing here. That's what I'm trying to say. For this, we need to be a little open towards robotics. Again, we have to look forward to create this robot, build this robot right here in India itself. Only then it will be possible. Because if we are going to depend on the imports and everything, this is going to never happen. That's what I'm trying to say. So if you have any questions regarding, you can ask. Hello?
Yes, hello, Santosh.
Yeah. So if there are any students who have any questions or queries, we can go ahead with that.
Can you explain, Santosh, what are the main elements of a robot? What it constitutes? Like you can say as a motor, this and that, because a lot of students are there.
Yes, I'll tell that. So the elements of the robots are like this. Basically, a robot, when you say the word robot, it means a very complex piece of machinery which has been controlled by a computer, which is programmed. So if a remote control toy is not a robot, the robot needs to have an onboard computer. It needs to have a program which is capable of performing a particular task. So in a robot, we don't have these ordinary motors. We have servo motors. So I would call it as they are smart motors. So these motors are programmable. So these servo motors, what they do is they take signal from the computer. So what program we write, what you saw, the actions, what you saw, this program was written in a machine language. They do not understand our language. They understand machine language. So we have to learn the language of the robot. We have to program them in their language. So when I'm telling the robot that you're supposed to take your arm out, you're supposed to take the arm up, you're supposed to hold the bottle, leave the bottle. This all is a program that I'm writing. Now this is a digital program. The computer is giving this digital program to the microcontroller, which is in the robot. Now what the microcontroller does is the digital program has been converted into analog and it is sent to the servo motor. So the servo motor gets that analog signals from the microcontroller. In return, it responds to exactly the way the signal comes to it. So that's how the action happens. So most of the job, you'll see 90% of the work, what we do, it's repetitive, especially in the manufacturing industries, so it's repetitive. So this job, we can program it in a robot and we can get it done from it. So it is done more precisely. We can do it for any number of hours without any worries. That's the basic fundamental of a robot. To get a repetitive job done with the best possible precision.
Santosh, what type of engineering is involved into this? Suppose the student now they get interested into making robot engineering. So what they should study? Well, they should study mechanical engineering or electronics engineering, or is it a combination of various types of branches? So some guidelines for our students.
That's a very, very nice question. So this is one question that I've been asked many times. to which I always say that robotics is not about any one aspect of the engineering. It involves mechanical engineering, it involves electronic engineering, it involves computer science, it even involves designing, and also there is a bit of a mathematics. So you need to be good at all these 5 topics. So if you are planning to build a very complex piece of a machinery, a very complex piece of robot, we need to make a team where we have students from different backgrounds. Like we need to have somebody from the electronic engineering, somebody from the mechanical engineering. So it's not any one person's job. It has to be a teamwork. That's how it can be done.
I have one question regarding use of robotics. We have seen that robotics have played a significant role in a space exploration and planetary exploration, like these rovers which are being sent, or for example our own Pragyan rover, which was supposed to land on the Chandrayaan moon in Chandrayaan 2 mission. Now there is Chandrayaan 3 is coming up. So how do you see the scope that current Indian space sector have opened up opportunities for a private player, and how this can contribute, and what are the possible opportunities in that direction?
You are muted, Santosh. Can you unmute?
See, robots are a very perfect piece of machinery for space explorations, because the kind of environment we have in the space, it's a very hostile environment. Sending a human being there, it's a very risky job. But sending robots is much more safer, and it's also much more economical. A robot can stay in a space station for any number of years or months. He doesn't have to eat, he doesn't have to sleep. So, it's the best piece of machinery we can send there. If you're looking at India, of course, the potential in India is incredible. I've toured almost 35, 36 IITs and NITs all over India, and I've seen the talent the students have there. It's incredible. But what I saw was missing was we are doing really great at the software part, because to develop a software or application, all you need is a computer, and that's it, an internet connection. But if you're looking forward to build something like this, we need a very complex piece of machinery, laboratories, tools. Also, you need a lot of funding. So this is somewhere we need to focus on. We need to pump in the funds. Similarly, like we have DRDO or we have ISRO, we also need to set up small institutions for particular states where the robotic enthusiast students can come there. They can gather there and they can make something. We need to do something like that for the students. So I guess if we do this, we'll see a lot of big things happening in India.
Yeah.
Hello.
Question.
Hello.
Yes, Bharat, you want to ask something?
Yeah, I was just to edit that. As he said that there is a robot used in the space. Actually, our Gaganyaan program, which is already flowing in after some time, the first initial phase before going to the man in the real mission, our robot will be fly. I think that robot is already it is already ready. That lady robot.
Yeah, I saw it. Yeah, it's incredible.
And one thing I want to ask Santosh, these robots, currently whatever you have made, is it possible that they can take this instruction in the different languages, Indian languages, other than the English? So state-wise, also those who are user the computer, robots, they also have a very good interaction with them.
Of course, it can take instructions in any language, because if you see at Google or Siri, they are capable of communicating in more languages apart from English. So that's not a problem. But taking it further, I would like to tell you that we don't have to look at robots in a way that they always listen to you in a language way. For example, let's imagine if you have sent a robot into space, so there is no way you'll be talking with a robot. We need a robot which actually is doing some physical work there, like it's maintaining the space shuttle, it's doing some repair job. That's the kind of robots we need. So for here, we don't need that vocal communication. We can simply give them commands from the earth, preloaded commands, which the robot can be capable of doing. Would be a better way of doing it, I guess. And instead of, I'm sorry if I'm wrong, but instead of making humanoids, we should be making robots specifically for that particular job, So because it's more important to get a job done than just have a robot which is just there for a namesake. We need a robot which actually can get the job done there. So that's how we should be building robots.
Yes, it is predefined job they can carry out. But why I'm asking, as a large number of students and the colleges and the schools, they have first initiation interaction with the robots. It is always by the interacting them with the robot by just talking.
Exactly.
It is the initial thing for the students only, not at the industrial application or any scientific application. Yes, you are true that they are always been given instruction predefined, like when Mars mission, whatever is going on, all the robots is already there. They are doing their job activities, whatever is predefined from here.
Sure.
Yeah, I think, Bharat, there is a separate subject coming up called as the space robotics.
Okay.
And there is a lot of scope into that. And still, if somebody starts making in India these robots, different type of robots which can be used in space.
Yeah.
Okay, there are many countries who will buy that. But the sad part of it, in India, we have got so many premier engineering institutions, okay, including ITs, ISC, and other engineering colleges. And we don't have any single company or institute who can develop robots for space as on today.
Yes.
So if we are successful in making a robot for space, I think there is a market for that. So young people, those who are here, I think they should think in that direction, how to make robots for now space. I don't know, there may be some problems in making that or designing that, but until we start doing that, we can't make.
Actually, Mathur sir, I just would like to add from my part, that is with the latest technologies in the field of programming, there is a very much wide scope. I would like a comment from Santosh sir also regarding the virtual simulation. Because the simulations will provide the virtual models for the working environment, and robots then shall offer advantages as a company. Because if you are as a you can say industrial, from the industrial purpose, and as from the point of view of a programmer as well. So it may reduce your cost also, and if I am not wrong, then it will produce virtually a 3D environment also even before the prototype is built. Say if we use these technologies, I was just looking for the Python programming with the help of RoboDK and all those things. Your comment, Santosh sir.
I'm sorry. See, the way I work is different. I'll tell you why. Because if you like, for example, if you see these robots were built first, then they were programmed. Because unless you do not build a robot, how would you be able to program it? Exactly. So once you build the robot, then you get to know the schematics of the robots, and then you can program it. So we need to focus more on the hardware part. I told you, we are doing really good at the application part, which is you can see in the phones and things like that. But we need to focus more on the hardware part, because if you are looking at getting things done, if you want to get some physical job done, we need to have a physical robot. That is very important. The first step is to build a robot, and then you can program it in any way you want to build it. What I just showed you was a very minuscule part of the program. You can program these robots for much more complex tasks than you can imagine. So that's what is my opinion. You need to focus more on the machine part. That's very important, I guess.
Yes,
that's not happening in India.
I have a question.
I have a question
regarding.
So, could you please explain how you are actually programming this robot? So, for example, suppose we call the robot right now over Zoom. Will the robot respond to us?
I'll tell you.
When you are doing particular task right now, when the robot did hi-fi or it actually shook hand with you, so how it is actually deciding a particular task, whether
exactly,
that's
what I'll tell you.
You are triggering the task, while explaining to you, or it can just trigger the way, the way the user, the way the person is behaving in front of him.
Yeah, I'll tell you. See, what you saw was an example of predetermined learning. So predetermined learning is very simple aspect of artificial intelligence and also the most safest part of artificial intelligence. Here, what self that I'm going to go there, I'm going to serve Santosh a bottle of water, I'm going to take it away from him. So it's predetermined, already determined. So I'll categorize these robots and I'll tell you how it is. So this is predetermined learning. Now, what you're talking about is fully autonomous robots. So it's for the fully autonomous robot means the robot is actually making the decisions by itself. It is programming itself. It is also deciding whether it is supposed to do the job or not by itself. So it's a very complicated technology. It's a very complex piece of software, but at the same time, it's also not very reliable and I would say dangerous because here you do not have complete control over the robot. What you just saw was I simply initiated a program and the robot was performing the actions in sequence. So it was a sequential program where the robot was programmed initially that to do the actions in step by step. So like he was doing a high five, he did a buy. These programs were written in a sequence. You get it? Now the same program, I can get it done from the robot by simply asking him to do. Let's say if I tell the robot, okay, do a high five, he will connect that audio wave with a particular algorithm that I'm supposed to do a high five, and then he'll perform a high five. But that's something which is in development. It's not ready right now. You get it? So this is what we are working on. So the robot will be actually responding to your voice commands and it will be performing that action which is predetermined. Now, for example, if I tell the robot that, okay, do one thing, just slap a person. So the robot is not programmed to slap a person or hurt a person. So the robot will simply not do that action. So it's a much safer version of AI, I believe. So this is something we can commercialize and we can actually get into use.
Yeah,
I have a question.
Yeah.
Yeah. So could you tell more about artificial intelligence, machine learning, and deep learning that's related to robotics? My question is specifically, does the robot, like by repeated actions, like whatever the commands have been given in a pre-decided order, does the robot learn, like in this case?
No, it doesn't learn. That's what I'm trying to tell you, that it doesn't learn by itself. We have to program it, manually program the robot. Now, I told you, the robot learning by itself is actually a very complex piece of technology. It's the future. Of course, it will happen in the coming days. But I personally feel at the same time, it's also a bit dangerous because the robot would learn things by himself. So, if the robot is in a bad company, he will learn some bad things. And then, the output might not be what exactly you need. So I personally believe the predetermined learning part of machine learning, it's a part of machine learning, the predetermined learning is the most safest way of introducing robots in a market for a commercial use. And that's what I'm trying to do.
By learning, I meant, does it improve whatever
it's
action?
Not, it's learning like, it's not learning actually, it's teaching, So I've taught the robot to do follow a particular path, go there, deliver certain food items and come back to the position. So when I want the robot to get the job, then I'll simply give it an order. So I'm having a complete control over the robot. Like if I want the robot to do a particular task, I'll simply just give it that command. I just have to click it that, okay, do this particular command, and the robot will perform that task and it will come back and it will stop. So that's exactly I'm looking at, how robotics can be used. It's a safer way. Of course, it's a very simple way of using robotics. We can do a lot of complex things, but as of now, I'm telling you, as of now, we are ready with this technology. In the future, of course, we will be looking at more complex things where the robot decides, whether to do it or not, whether to do it in a different way. This is what we can do in the future.
One more question, Santosh. About your service robot. How do you look at it in comparison with the programmable robotic hands? And is you also get these programmable robotic hands, which actually are able. So you get the kitchen, the kitchen robotic hand, which it can do operations in kitchen, or it can do, the industrial operations. So how you look at it when you uh, when you
So you're talking about the
from
you're
the
talking about
perspective of
the you're talking.
sequential task and the learning or decision making.
No, I didn't get your question. Are you talking about the robots which are used in the hospital, the operation, which do the operations exactly like that?
No,
You're talking about that?
typically the typically the what performance you have shown of your service robot, it can be equivalently done by a robotic arm, programmable robotic arm. uh, the
So
open
this
source.
is exactly, yeah, this is a programmable robotic arm. What you saw in the robot on my right side, on the left side, these are programmable. You have to program them.
Right.
But the only difference is that you program it, it will only perform that action when it is asked to. When I give a command that okay, perform this action, it will do that. It will not just do it by itself. That's the difference. You get it? That's the difference. It is programmed to. The thing is there, it's a hard work. We have to teach the robot. We have to program the robot for various different tasks. Whatever it might be, even giving you a head massage or a full body massage, or doing any kind of a job. But it has to be programmed first. And then if I want the robot to do the task, it will do it only when I give the command. That's the difference. You get it?
Yes.
For example, if you're talking about going in a kitchen and making a food also, that can also be done. It can also be predetermined. The only thing, the only difference is that the robot, all the things have to be kept in a certain place, where the robot knows that, okay, here we have kept this part, here we have kept this item, then he'll be able to do it. It's not that he will find by himself that this is the egg, this is the masala, or this is the, spices. You get it? That's
Correct,
how it is.
correct. I get that.
Yeah. One applicability point of view, I have something to come in my mind, which is when you say that we can use this programmable robots and they have vast applicability. There's something which I observed recently is in a hospitals where there's a COVID ward. They have designed an trolley which can automatically reach out to the patient's bed and deliver a food. And there is one thing in my mind. In addition to that, one can improvise automatic delivery system in such scenarios by simply clicking a button. That robot will, that trolley or that structure will go and vend automatic vending certain things like water or any other necessary things. Like there are automatic vending machines which are available in railway station, mostly in European or foreign countries. What you see, can we integrate those for such purpose? This is something which I
Yeah,
just came. Yeah.
exactly. See, the right side, what you're saying, MSR, you can actually use this robot in a COVID facility. Let's say we have 100 beds there. So this we'll just have to program the robots in a way where it will follow through a certain path. It will deliver the kind of medicines it is supposed to deliver on a particular bed number, and it will come back where it was automatically. Only difference is that first we have to initiate the program that you are supposed to do this job. It will not decide by itself.
Yeah, but now I have one thing in that there is this instead of robotic hand, if we convert this, just the wheels will be doing a job to reaching out to the place, and if you just attach these automatic vending machines, whereby just clicking this button, it will, suppose there are water and then there is a chips available in the machine, so the patient can just click on the button and he will just get those things. So
we have already, we have already, that robot is already in development right now, because what you're seeing here is a much more complex robot. We don't need much complex robots like these, having hands and like that. It's already in the production. It's already in the making, where we are developing a humanoid robot like these, and we are having autonomous rovers like this. And the actually body, we can put a trays, we can put an automatic vending machine, whatever you want there, and it will simply guide itself through a particular path. So what happens is, example, I'll give you an example. Let's say we have 10 robots. The COVID robots, what you're seeing right now, I'm sorry, most of the robots are being manually controlled. They're like remote control toys, nothing more than that. So somebody is simply having a remote control, the robot is going through the beds and all that, and it's doing the job. But that's a very tedious job, because to control a robot, we have one person. So it's not a very feasible thing to do.
Right.
So with this robot, you know what you can do? Let's say we have 10 robots like these, and they're supposed to assist 500 beds. So, and for the 10 robots, we'll have 10 people. But the advantage is, so for the 10 robots, we'll just have 2 people, or let's say one person. All that person has to do is simply give the robot a task that, okay, you go, you take care of these 10 beds, you serve them the food, and you come back.
Yes.
And
Yes.
it will do the job automatically. So he's not controlling the robot. He simply gave the order. The robot is getting the job done by itself.
Yes.
He can go on to the next set of robots, and he can give them instructions. That's what we are working on. So
Yes.
what is practically possible, we are working on that solutions.
So
It's
can
not
it
that,
be
okay,
made,
after,
can it be made like a line following robot, and you actually set up the lines on the floor where the beds are placed?
Yeah, exactly. See, with line following robots, the problem is that we have to set up the lines and everything. Then we have to maintain these lines. So it's a very tedious thing. Here, you don't have to think about all these things. We just have to simply place the robot. We have to map it that, okay, this is how the robot is supposed to travel and come back. It's a very simple thing. It's not a very complex thing to do. We can program the robot in a matter of few minutes, and it is done. You don't have to worry about putting lines and all these things. And the robot is much more precise than what a line following robot is actually. I sure it's almost a 1 millimeter of precision what this robot has. So it cannot lose the path unless you make it lose the path.
So that one additional I have something which came to mind, that patient itself will have a button like what you have in aircraft, that you click, and then this lady, the flight attendant will come and ask, right? So as soon as the patient clicks the button, the robot will be sit there standing in the corner, will just come there. The patient should be able to choose what he wants, and just he should get.
Exactly. That's exactly what we're working on right now. And we have made it happen. We are not saying that we will be doing it, or, after some time we'll be doing it. We have already done it.
I have one question. What is the public perception of robots? In the sense, going ahead from Vaibhav's example of airport-based kiosks and hospital robots and all, I watched a video long ago. In the country of Japan, they have near their rice fields. They have near the rice field a machine or a robot sort of a thing which would thresh their rice for them. It will dehusk it and provide different grades of brown rice. And it's an automated thing. It's a small kiosk where you have to pay some money and it will do this thing automatically. So if such a thing were to be, say, installed somewhere in India, what do you think, in your opinion, how would people receive it, or what's the perception right now for such kind of involvement of technology in everyday life? What would you say for this?
See, it will happen. I told you, because with coming years, the first what the robot was costing 1 crore rupee, now it has come down to a few lakh rupees. In the coming year, it will go to a few thousand rupees. So the very deciding factor is going to be the price, because in India, people are not going to buy a 50 lakh rupee robot just to get something, agriculture job. So the day the robot is in a very feasible, comes in a very lowest price, even the farmers would go and opt for these kind of robots. And of course, agriculture is one of the best things where you can use robots and automation.
Okay, thank you.
Yeah. Hello.
Yes. Anyone else wants to ask? I'll ask otherwise 2 more questions. Please. Any student?
Hello, sir.
Anyone on the YouTube?
Hello, sir.
Yeah.
Sir, I'm from the Academic Institute from Nasik.
Okay.
Our professor teams have visited last year at IIT Bombay the robotic competition. Firebird 5 robot they have prepared, and they also got the prize also. Now we are in interest for making more students to interact with the robot, or more students to come across and go for some kind of robots to make. But the first things I have observed from the student, that what Santosh sir has just explained, first prepare the robot and then program it. But initially the students they are thinking that first we have to do programming and then according to we have to do the structure. So that the concept sir has very clearly mentioned. The another thing I want to ask sir, that whatever the predefined robots is there, we are just making the programs and they are doing the task by simple clicking. But for
Exactly.
doing the multiple tasks, which the task may not be in a sequence. So for such all tasks, the programming must be done previously, and just by suppose a simple word, go straight, go left, go right, the command will execute. So for
No,
doing
no.
such command, the software or the language, what you can suggest, that what are the best language software that student may get familiar with easily for the diploma and degree level?
I got your question. So as you said, and I already mentioned also that robots do not understand our language. We don't program a robot like go right, go left, go up, down. That's not the kind of language the robot understands. We have to first learn the language what the robot understands. That's the machine language. So there are various types of machine language, starting from Python. I myself am really comfortable with programming in Python. So what you just saw was Python programming. So so you need to understand you have to be really good at programming, because in a sequential program you are putting yourself in a virtual world. For example, the task what you saw the robot was doing, when I'm programming these robots, I'm in a virtual world that, okay, when I'm programming it, the robot will do certain kind of action. So to get there, of course, you will take some time, but that's how it is done. You need to learn the robot's language. It's not that the robot is going to know your language. You need to learn the robotic language, the machine language, and then only you can program a robot. And for that, you need to have a robot first, because you cannot just write a program for which you don't have a robot, right? You need to have a robot first. So build a robot, whatever it is. It might be a 3-axis, 4-axis, 8-axis robot. It might be a very simple robot. Try programming it. This is how you will develop the skills.
Thank you, sir.
Yes, any other question by anyone? Yeah, Santosh, one thing I want to ask.
Yes, sir, please.
Now, suppose I got one partner who has got good, he wants to finance, and I want to open a robot shop. Maybe in future, like other items you are selling in the market. So can I start a robot shop, and where I start selling different type of robots or start marketing robots? So we may have some standard small robots in the shop to show to the people, okay, these are small 6-inch size robots, 12-inch size robots, it will do this. So we should know what type of robots have been developed in the country and what is available for what purpose. So this type of business people may start in future, just thinking they may start something doing that if more and more robots are available. Or he can also say, okay, I will get you a specially robot designed by somebody. What is your requirement? Come on with your requirements. Correct, no? Same way I read in the newspaper that government of Delhi, it was a statement, I think, by Chief Minister, they are buying 400 robots for cleaning the gutter line of Delhi Municipal Corporation. They don't want that to clean those manholes. And people should go because of there are no lot of gases are there, methane gases, and so many people die. So they are buying small size of robots. I don't know from where they are buying. I don't remember. Last year it was there in the newspaper. A small size of robots they are buying, which will go into the gutter line and clean everything and come. So that way there are many types of robots will be available in the country right now. Also may be available. Different people are making, designing, producing. You can't say that there is a mass production of the robots because it is very costly. It is very costly, robots. So can just as a general thing, we know what type of robots are available here in India, what different functions they can do.
So I don't think it will be good for me as a manufacturer of a robot to comment on this,
Okay.
because it will be a very controversial statement. But still, just to talk a little bit about it, I would say that as per my idea, most of the companies, not all, I would say 80% of the companies, they are simply importing robots from China, and they are labeling it, branding them, and they're selling it here in India. So these are basically Chinese robots, cheap Chinese robots, which are actually of no really good use. So that's the reason I'm trying to, get into this market. I'm myself making available 5 to 6 different types of robots now, which will be available for sales. So the idea would be that the buyer would just not be any researcher or any school or institute. Any person who is a robotic enthusiast can simply buy the robot. I am manufacturing it as a OEM, original instrument manufacturer. He can label it, he can brand it, he can reprogram it, he can modify it the way he wants to, or upgrade it, and he can sell it further. So that's the option I'm keeping by not branding my robots. I'm not branding my robots. As you can see, this robot is actually being made for another company. So that's how I'm making it happen. So basically, give a platform, make a robot, a basic platform. You sell it out, and the buyer can upgrade it, or he can reprogram it or modify it and sell it further.
As you know, DRDO is also in the process of developing or procuring some robots where for the this bomb disposal squad. Now manually we have to do that. So they want to use robots for that particular purpose. Suppose there is a bomb lying somewhere, the robot will go and it will defuse that. Something like that.
Yeah, sir.
Okay.
I mean, it will be a really, a privilege if I get to work with the DRDO in a certain project. I would be really happy to assist or work together on a project where I can really provide my expertise, where they can make a good robot which can get the job done. Because I told you, in the 20 years of experience, that's one thing that I've learned is the manifesting ideas into reality, and that is something we can get into use.
Okay, thank you.
Thank you, sir. Thank you, sir. It was a pleasure being here on the talk show. Thank you so much.
Thank you for sparing your important time and accepting my invitation to deliver talk. Basically, on technology, we wanted to share our knowledge with the young students. So I have invited all ITI, diploma, degree, anybody who is interested in learning and sharing knowledge was welcome.
Thank you. Thank you. It was a pleasure being here. Thank you so much.
Now, over to Chintamani, please.
Thank you, Santosh Hulavle. It was very pleasant experience and very enlightening experience looking at the robots which you have developed. And I'm sure all the students who are attending on YouTube and through Zoom platform, they are really inspired to take up their careers in robotics. And I'm sure they will take that inspiration from you. Thank you so much, sir.
Thank you. Thank you. The pleasure is mine. Thank you so much. Bye-bye. Sir, I can log off now, sir? Is it okay if I log off? Mathur, sir? It's okay? I can log off now?
Yes. Yes.
Mathur, sir, at the moment you are muted.
Yes. Okay. Santosh, if you want, you can attend other talks also if interested.
Sir, I'll try, because I got some things to do more.
Okay.
I'm stuck with some projects, so that's why,
Okay.
Yeah.
Welcome.
Yes, thank you so much. Thank you. Bye-bye.
Thank you.
Okay, Chintamani, has our professor joined?
Yes, sir. Satya Chakravarti has joined.
He is joined. Okay, so we can start.
So good afternoon, everyone. As we are moving towards the session 2, we have here Professor Satya Chakravarti from Aerospace Engineering Department of IIT Madras. Good afternoon, sir. It's great pleasure to have you on day 4 of the awareness webinar series on advanced technologies, and we are really excited to attend your session. Uh, so before we start this session, let me officially introduce sir. So Professor Satya Chakravarti is a professor of aerospace engineering at the Indian Institute of Technology, Madras, Chennai, India. He received his Bachelor of Technology degree in Aerospace Engineering in the year 1991 from IIT Madras and went to obtain his Master of Science in Aerospace Engineering degree in 1992 and Doctor of Philosophy in 1995, both from the Georgia Institute of Technology, Atlanta, GA, USA. After a brief postdoctoral stint at Georgia Tech, he joined the Department of Aerospace Engineering at IIT Madras in the year 1997, where he was appointed assistant professor in 1998 and associate professor in the year 2003. He is serving as professor there since 2009. In between, he has visited Georgia Tech in the 2000 and 2001 and Technische Universität Darmstadt in 2002, 2003, 2006, and 2009. Professor Satya Chakravarti works in the areas of propulsion and combustion and researches on different aspects of combustion in gas turbine and rocket engines. He heads the National Center for Combustion Research and Development at IIT Madras, supported by the Department of Science and Technology, Government of India, with a fund of rupees 47 crores, which is augmented by research funding over rupees 54 crores with 33 industry projects on different aspects of combustion in automotive, aerospace, thermal power, and fire research. The NCCRD in the largest of its kind in the world with a 5-story building that houses the state-of-the-art facilities on combustion research, including a 33-meter tall microgravity drop tower. Recently, Professor Satya Chakravarti is also heading the Center of Propulsion Technology supported by DRDO with funding of rupees 84 crores. He has nearly 80 peer-reviewed archival journal publications to his credit, presented over 200 conference papers, delivered many keynote plenary, invited lectures, visited many universities such as MIT, Cambridge, TU Berlin, TU Munich, etc., and industries such as GE, FM Global, etc. He is on the editorial board of Progress in Energy and Combustion Science and is a colloquium co-chair on solid fuel combustion for the International Symposium on the Combustion Dublin 2018. He has been awarded the HAL Prize for the Best Undergraduate in Aerospace Engineering in the year 1991, the Young Engineer Award by the Indian National Academy of Engineering in the year 2003, the Young Faculty Recognition Award by IIT Madras in the year 2009, the Dalmi HEMSI and ACR HEM Award by the High Energy Materials Society of India in the year 2009, and the DRDO Academic Excellence Award by the Defense Research and Development Organization in the year 2009 and 2016. Professor Satya Chakravarti is the director of Astro Velos, a startup company aiming to produce micro gas turbines for decentralized power generation, and a shareholding advisor to Agnikul Cosmos, a startup company aiming to make mini launch vehicles to launch micro and nano satellites into space orbits. He's ideating an air taxi startup for intra-city air launch micro and nano satellites into. He's ideating an air taxi startup for intra-city air commute and regional air connectivity with existing fleets of chartered helicopters and fixed-wing aircrafts, and another startup to design manufacture electric planes for the same purpose in near future. He is involved in efforts to set up a consortium of industries and R&D institutions for making large-sized around 100-seater conventional planes and turboprop engines for them in India with governmental support at the highest levels to enable regional air connectivity to take off all across India at affordable levels. He has been invited to deliver a talk at the Mahindra Technical Academy on their great ideas for tomorrow, which is known as GIFT program. His web presence includes a TEDx talk in India's space program and his 55 lectures on a graduate level course on combustion on YouTube through National Program on Technology Enabled Learning. NPTEL. With this, I invite Professor Satya Chakravarti to start his talk. Over to you, sir. So you are muted.
You can hear me now?
Yes, sir.
Welcome, Professor Satya.
Thank you, sir. Thank you, sir. Is it possible to allow me to share my screen?
Yes.
Yes, sir. You can share it now.
Sure. Right. Are you able to see my screen?
Yes, sir. Your PPT is visible.
Very good. Yeah. Good afternoon to all of you. Thank you for inviting me to give this talk. My topic today is flying taxi development in India. I'm Chakravarti, Department of Aerospace Engineering, IIT Madras. What we aim to do here is essentially to develop high mileage flying taxis for door-to-door travel in cities. The objective is to be able to travel anywhere within cities within about 10 minutes. Imagine a place like Bangalore or Bombay where going from like a very short distance of about 10 to 15 kilometers, it normally would take about 1.5 hours. So we want to actually see if we can cut that short to about 10 minutes. And cumulatively, everyone in urban areas actually spends about 3 years of their lifetime sitting in buses or taxis or auto rickshaws or whatever that takes them from their home to their offices and back on a daily basis. And that's actually a very long time of human resources that is getting wasted. And particularly in intra-city travel, we would like to cut that down on a daily basis for almost everybody, so that we will try to save on human resources. What ISRO has been doing, for example, we expect to build out of India for the world. So this problem is there everywhere in the world. Most cities around the world actually are congested. They have traffic issues. They have gridlock, traffic jams. They have all these problems that I just talked about. So it's not just an Indian problem. So if we are able to produce a solution in India, we should be able to get the rest of the world to adopt as well. And since I said almost everyone, we want to actually get to use this. We essentially are saying it should be affordable. And so through the talk, we will actually find that doing an electric plane, for example, will make it very affordable. And I will explain that in my slides. So our goal here is to essentially make cities spread out in an affordable way, where people can actually decongest themselves, live away from what their usual amenities are, like offices or schools or whatever it is, so that they can commute very quickly from one place to the other. Cities will actually spread out, just like how buildings grew taller and taller because we had lifts or elevators, enabling that. So it's very similar approach here for the city. So let's actually look at the qualities of what would be an urban taxi that is ideal. And then we can actually formulate how to make this taxi, and then we see where we are. So the first one is it has to be very safe, because we are actually flying over populated areas, first of all, particularly human inhabited areas. So we have to make sure that it does not fall at all. It shouldn't actually crash. So the way we actually try to do that is with electric aircraft, we have multiple rotors that are replacing one large rotor that you would see in a helicopter. With multiple rotors, we now have the ability that if one of the motors actually fails, you'll still have others that can take over. So you have a significant amount of redundancy without too much of a weight penalty. So today, for example, if you use helicopters for this purpose, helicopters have huge limitations on operations in terms of regulations. One of those is, for example, you need to have a twin engine helicopter if you have to take off from elevated platforms or let's say tops from terraces of buildings. So, and similarly, you should have significant clearance around that building for helicopter to take off, at least in one direction. It should not be surrounded by a lot of taller buildings and so on. Third restriction is a single engine helicopter can actually function only from half an hour before dawn to half an hour after dusk. So that gives you probably about 13 hours of operation instead of nighttime operation. So nighttime landing is permitted only with twin engine helicopters. So if you have all these kinds of restrictions and you have to allow for twin engine helicopters to operate, it becomes extremely expensive to operate twin engine helicopters, which is the reason why we have not seen helicopters in wide use in most parts of the world, although there are a few pockets in the world where a helicopter-based taxi service actually is operational. And of course, in certain parts of the world where it's operational, it is meant for elite class, not a lot of people. I think there is one place in Brazil, like a city called Sao Paulo, where there are about 300 helicopters that operate, which could be affordable by a lot of people. But in comparison, I think India, on the whole, India has only about 180 helicopters. So the reason is twin engine helicopters are expensive to own or acquire as well as to operate. We are essentially looking at two engines for the purpose of redundancy, and one engine exactly will replace the other in case of a failure. One engine will replace the other in terms of in case of a failure, which means that you are carrying one big extra weight. Whereas if you now replace that one rotor by multiple rotors and corresponding motors, and let's say you try to do about 8 motors or 8 rotors, 10 rotors, any of those kinds of numbers, you don't expect like half of them to fail. So you're not essentially doubling the propulsion and its weight and the power for redundancy purpose. You're actually giving only a little extra. So that way, the aircraft is extremely efficient in terms of its weight, and still offers redundancy and safety. That is the first point. Similarly, because you're actually having a large number of rotors, they in turn become smaller. So one big rotor actually gets replaced by multiple small rotors. And this is first of all possible because you're not having a combustion engine that is having a shaft, that the shaft has to be transmitting the power through gears and so on. That makes it actually extremely heavy and complicated and cumbersome. Instead, we are actually only running wires from a battery pack to these small motors, which are compact, that are whose shafts are directly connected to these small rotors. So when you now have these small rotors, they end up actually turning at much higher RPMs than a typical RPM of a large rotor. And when you now have these small rotors running at high RPMs, the noise that is coming out of it actually is in a frequency range that is on the higher end of what is perceivable or perceptible to the human ear, and correspondingly, the human ear is less sensitive to those frequencies. And therefore, you can ensure something that is very quiet. And we will also see in the implementation that we have, we actually make these rotors also shrouded by ducts so that we can cut down the amount of noise, and we can also make some implementations on those ducts to particularly cut down the noise. So we can have like a lot of noise abatement strategies adopted in these types of motors. That is the second point. And this is very important because world over, when people are actually looking at these urban air taxis, they are very much sensitive to the fact that helicopters make a lot of noise. You don't want, let's say, for example, this kind of planes become very, very commonplace. You will have you will have like a plane that is taking off from your neighboring apartment or something, and you're just sleeping at that time, and you get it completely disturbed. So you don't want to go through that, right? The other point is actually it's pollution free, and because it's fully electric, so there is no emissions, and there is no carbon footprint on board through onboard emissions. The fourth point is electric aircraft particularly is actually going to be much cheaper when compared to a combustion aircraft. And that is because when you now compare electric vehicles on the road, like cars, what people have done so far is to pack a lot of battery into the car and put it on the floor so that the vehicle will be quite stable. But in effect, actually makes the vehicle more heavier. But you can't actually afford to do that with planes, because you have planes have to fly, so you can't actually make it heavier. So effectively what happens is these planes cannot really go very far. The ranges are actually quite restricted when compared to the combustion counterparts. The interesting thing is the combustion counterparts actually have like very high ranges which are never utilized in a single trip. So the range is actually very superfluous. A shorter range is pretty good enough for our purpose, all right, and particularly for the purpose of air taxis, and therefore you're packing less battery into the aircraft, and that essentially makes for the aircraft to be actually cheaper when compared to a combustion-based aircraft, which is opposite of how electric vehicles have been, or road electric vehicles have been so far, which is they are more expensive than their combustion counterparts. The reason is batteries are actually the most expensive items in these, and that essentially means that cars are actually more expensive because they're trying to pack a lot of battery. Whereas in planes, we don't try to pack a lot of battery. We are okay with the short range, and therefore the price point of planes actually can become cheaper when it becomes electric. Similarly, OPEX is actually extremely also cheaper because electricity for recharging the batteries after so many trips is quite cheaper when compared to filling aviation turbine fuel into the tank. And third, the maintenance is actually extremely less because you hardly have any moving parts except for these motors. And electric motors actually are, will run continuously for very long times, or they are very robust. So you hardly have any maintenance issues. The rest of it is basically batteries and wires. You don't really have too many other gears and shafts and all of that stuff, and combustion or hot spots. Any of those things is not there. So maintenance is extremely, the part count is less and all of that stuff. So the capex opex being less will actually make it affordable for a taxi application. We want to actually have a high mileage in a single charge, which is basically meaning that we want to get as much range as possible. And we will see some examples of air taxis which do not offer that versus the other ones who actually offer that. And definitely we want to have as high a mileage as possible in a single charge. At the same time, we also want to have these air taxis be capable of doing multiple short hops before a single charge. So those taxis in the world that do not have like a long range, they are limited by the amount of distance that they can travel before they have to get a single charge, which means that every time after completing that kind of a short distance, they will have to stop for charging, or they will have to go through a battery swap, and the battery swap is not actually acceptable even in road vehicles, and it is not going to be very reliable for air applications. Therefore, you don't expect that battery swapping will be accepted at all. And even if it did, those batteries will have to actually go through so many charge recharge cycles within a short period of like about 1 or 2 months, and the battery will die. So that makes it more expensive. So you want to be able to actually make multiple short hops before you go through a single charge. That ties with the high mileage, but in addition to that, we want to actually fly at low speeds. Because when you try to go at very high speeds, by the time you actually take off and accelerate to that particular high speed, you would have already covered some distance. And then from there, you have to decelerate back to 0 speed and then land. So the amount of distance you will cover will necessarily have to be large if you clock high speeds. And therefore, you need to have low speed as a requirement for short hops to be possible, in addition to actually having high mileage. This combination is not so easy to crack, and that's what we would like to highlight in what we're trying to do here. We would like to actually make it as compact as possible so that it can be very close to a door-to-door commute, and that's because you don't want to have something where you have to go to a takeoff point which is like a few kilometers away from your home, and you probably will have to walk, or you have to take another mode of transport like a taxi or an auto rickshaw or whatever it is. And from there, you have to take another, this plane, and then it lands somewhere. It is still not close to your destination. You have to take another mode of transport. So this three-legged journey makes sense today for planes or whatever it is. For example, if you want to go from Chennai to Delhi, it makes sense to actually go take a taxi from my home to the airport and then take a plane to Delhi, and then another taxi from there to wherever my destination is in Delhi. But that's not going to work if I actually have to go within Chennai itself, having a three-legged journey, right? So, which essentially means that I want to be able to have this plane land as close to my home as possible, like typically my apartment terrace, or and similarly the office that I'm going to, an office terrace, or an apartment complex within the compound that is like an open space. So whatever is the smallest space available, we should be able to accommodate the landing and takeoff of this kind of an aircraft. There is a requirement for a quick occupancy as well when you're now trying to look at very short distances. Typically, there is a graph that goes for the larger the number of passengers, the longer the range, or vice versa. So since you're actually looking at very short distances, we want to actually have very low occupancy, because quick occupancy, in the sense, if I'm actually taking a taxi, I want to make sure that I'm not going to wait for any other passengers. It's not like a shared taxi. So because I'm actually anyway wanting to go very quickly, and if I have to wait for other passengers, that quickness actually is lost. So we want to actually try to make it like very small number of passengers, that as much as possible. And similar to the point of having a compact aircraft that is going door to door, we want to make sure that you don't really have the necessity for a lot of infrastructure, like what is called as vertiports or helipads, that have to be specially built for this purpose in separate areas or designated spots in the city and so on. That becomes like infrastructure intensive, and so that it becomes more expensive. So we want to try to utilize existing spaces to do this and not have too much infrastructure. It should be easily certifiable, which means that we shouldn't have too many complex moving parts. Like for example, you would come across what's called as tilt rotors for vertical takeoff and landing, and then forward motion, and that is actually a big no-no. While there, we also want to make sure that the high mileage offers the possibility of you going from one city to the other, which is like not too far, right? For example, a Bangalore to Mysore, or a Mumbai to Pune, or a Delhi to Chandigarh, or any of these kinds of pairs of cities which are within about 200 to 300 kilometers, right? We should be able to travel as well. So all these combinations is what we would like for an ideal urban air taxi. So keeping this in mind, what we have done is to develop a plane that sort of looks like this. This is still a conceptual picture and not the true picture, because we have some IP that we don't want to reveal on how these rotors are placed with respect to the wings. So this is sort of like a slightly different rendering of that. But overall, the plane looks like this. It has a wing, and it has a forward tail called canard, and then the cabin looks very much like this. The form factor of the cabin is pretty much the same. So what we are essentially aiming at is to have a 4 meter by 4 meter footprint, the wingtip to wingtip, and nose to tail. It has a 200 kilometer range. It's a two-seater or a 200 kg equivalent payload. And we want to fly at about 150 kmph cruise speed. It is faster than what you will go with a car and not get stuck in traffic, but it's slower than most of the planes, typically helicopter speed. And it is capable of vertical takeoff and landing. It is fully electric. The cost for the passenger will be very similar to road taxi. Similar would be 1.5 to 2 times approximately. There is some IP, as I said, we have actually developed for making it very compact and slow flying. I'll talk about that a little later, but that has led to patents being filed. And initially, we expect it to be a human-piloted version. So if you're actually operating as a taxi, it'll essentially be like only for one passenger, and that's okay for most part to begin with, because most Uber, Ola rides during daytimes are all like single passenger rides for office-going people going from one point to the other to attend meetings or whatever it is. So this is still good for the initial market. Over time, we expect that autonomous flights will actually be allowed, in which case we can remove the human pilot. It will significantly lower the cost of operation because the pilots will actually take a lot of money otherwise. I mean, not the conventional pilots, even like a slightly better than a Uber Ola driver, right? Kind of pay will mean that there is a significant chunk of cost associated with that. So, but if you make it an autonomous plane and that's allowed by the civil aviation authorities, then the cost comes down. We can actually take 2 passengers at the same time and so on. Since it's actually human piloted, we expect that we don't really require any new laws. It can actually take off similar to how helicopters are allowed to operate today in what's called as NSOPs or non-scheduled operations. And there is a certain protocol or a standard operating procedure for flying helicopters over cities today that can be followed as such with the human piloted version. So why not helicopters itself is one of those questions that we will ask. So we can compare between what's the helicopter and what's a smart eVTOL. eVTOL stands for electric vertical takeoff and landing plane. So first thing about helicopters is it's not really a scalable option. It's very expensive to operate because of high fuel prices. In addition to being high, the fuel prices tend to fluctuate, which means that it's very difficult for the operator to foresee what will be the costing that is required for this. And helicopters actually are very high on maintenance. There are way too many moving parts, gears and swash blades and all of that stuff. And it is definitely piloted, so the pilot fee is pretty high particularly for helicopters. And it's very hard to manufacture. Most of the helicopter designs today are actually from the 1960s, 70s, 80s. So there are hardly any modern helicopters using modern manufacturing techniques and stuff. So this is pretty bad. The other thing is it's not very urban friendly because it's polluting. It's very noisy. I think we haven't gone through this. And there are also a lot of helicopter crashes that we come across, but these are typically those offshore oil rigs where you have like a lot of crosswinds and so on. So that's where we have actually come across a lot of crashes, plus pilot error and all of those things. Whereas if you now look at the smart eVTOL, assuming it's actually autonomous flying is enabled, it can actually bring down the cost of operating to about 90% less when compared to helicopters. But without the autonomous operation, if you have a human pilot, you will still actually have about 50% less to operate. And that's because electricity is relatively cheaper and you have 100x less moving parts. Therefore, the maintenance is actually extremely easy. And it's also easy to manufacture for the same reason that the part count is less. And it's quite urban friendly because it has 0 emissions. It's about 100 times quieter than helicopters. And we talked about the safety. It has these redundant distributed small motors that makes it also quieter. So fundamentally, helicopters are not suitable for mass urban taxi. And there's a reason why you also don't see it in the skies as often. So what we expect is that if we now make these smart eVTOLs, that's what is going to make urban air taxis possible. So let's actually look at a comparison with about 6 of these that are available around the world with what we are planning to do in India. So there are actually about something like about 300 plus projects that are developing these kinds of eVTOLs. And many of them are actually more like college projects, which are just like projects. They're not meant to be like companies. They're not meant for manufacturing and so on. The college students participate in competitions. So they stop at like designing or at best prototyping, or prototyping more like a subscale version and so on, but not necessarily a full scale product, right? So at the leading level, these guys are actually where it is, the situation is, right? So on the left-hand side, we are actually seeing left-hand side as well as the top right-hand side. We see versions which actually have wings as well as vertical rotors for takeoff. So the first one, for example, is Dobby Aviation, which has like about 241 kilometers range, and that has 10.7 meters wide wingspan. And the cruise speed is 322 kilometers per hour. And it actually has 5 seats and it is piloted. It has raised a lot of money and it has gone public recently. It is going through an FAA certification. and it has stilt rotors, and that's one of those reasons why the certification is taking longer. Similarly, there is another American company that started much later, only about a couple of years ago, and whereas Joby has been around for more than 10 years, working closely with NASA, but Archer is just started recently. It has a 100-kilometer range. It is 11 meters wide. It has 241 kilometers speed. Seats 5 people. It's piloted and also raised quite a bit of money and got gone public very recently. And it's going through FAA certification, and it has stilt rotors. Wisk, on the other hand, is actually supported by Boeing and Google. It doesn't have tilt rotors. It has a separate one single rotor for forward flight, but has a whole bunch of vertical rotors for the vertical takeoff. It has only a 40-kilometer range, and it has 11-meter wide wingspan, and it has a speed of about 160 kilometers per hour, which is okay. But it is actually an autonomous plane. It has only 2 seats. And for the reason why it is autonomous, they are actually going through a certification with the New Zealand Civil Aviation Authority. The tilt is not a problem for the certification, but autonomous is where the issue is for certification in the US with FAA. Lilium on the top right actually has a 300-kilometer range, which is good, but it has a 12-meter width wing, and it has 300 kilometer per hour speed, and it has 5 seats. It's piloted. It has raised a lot of money and gone public. It is going through a European certification, I think also US certification, and it has what's called as tilt fans. The bottom two on the right hand side, the Volocopter and EHang, are essentially like big drones, which is somewhat similar to helicopters itself in the sense you have vertical rotors only, they don't have any wings at all. And for this reason, they have to keep on using their rotors. They have to keep on turning their vertical rotors in order to even balance the weight of the aircraft throughout the flight. And that actually guzzles a lot of power, which means that the range is actually only about 35 kilometers. That's a huge problem, 35 kilometers. And Volocopter actually has a much higher width because it has that huge ring over which those vertical rotors are distributed. It's about 9.5 meters wide. Its speed is quite low because it just has to go like a helicopter. So it has only 110 kilometer per hour speed, and it seats 2 people. It's piloted. It has raised about $450 million, and it's going through an EASA certification. It has only rotors, so it doesn't really have to tilt. So that's a less complex mechanism there. EHang is a Chinese product which has only about a 30-kilometer range. It has 5.61 meter width, which is reasonable. They have a speed of about 130 kilometer per hour speed, and it seats 2 people, but it is autonomous. It has also raised money and gone public, and it is going through a Chinese certification, and they will be pursuing a US certification as well. This also has only only rotor, so it doesn't really have any tilt mechanism. What we do in India here in the work that is happening at IIT Madras is we target a 200-kilometer range, and we have only a 4-meter width, which is actually the most compact when compared to everybody else. We target a speed of about 150 kilometer per hour for this 4-meter wide wing, and that's actually very, very difficult because, and we will explain this a little later. So when I'm having very short wings, I have to necessarily fly fast because my wings or the wing surface area is so low. Unless I actually fly fast, I cannot generate the lift required. But at the same time, conversely, if I have to go very slow, typically the wing width has to be very, very large, like particularly what you would have seen with gliders and so on. So that contradictory requirement of a compact aircraft and a low speed is something that is an aerospace challenge that we have addressed over here. So we have raised only about a seed funding. We started only a couple of years back and started looking at taxis only last year. And we are actually looking at DGCA certification as well as EASA certification. We don't really have any tilt mechanism. We have separate propellers for or rotors for the forward flight and for vertical takeoff. The conceptual drawing here actually is misstating that way. And that was deliberately so because we didn't want to reveal what exactly we are doing. So this essentially is what we call as a E200, which is meant for 200 kg payload and electric. And it's perfect for an urban commute, and more meaning you can also do a long distance commute and not necessarily an urban commute. So if you now look at what exactly it means in terms of travel time and cost, right? So these are actually graphs that have been put out by other people, to which we have added our own graph. So if you typically take like a 60-minute personal vehicle, let's say you get into your own personal car and then do a 60-minute ride, you will know what your cost is to operate. But if you use the Uber Black, for example, that's like a Uber Premium, it'll take 70 minutes because you still have to actually wait for the car to come by and all of those things. And let's say in New York prices, that would actually mean about $150. An equivalent helicopter ride actually costs more than $1,000, $1,775, and it takes only 27 minutes. And that's because you have to actually go to a helipad from where you are and get down at the destination helipad, and then from there you again have to take a road taxi or something to get to your actual place where you want to be. This will also be the exact same kind of situation with the other urban aerial mobility providers that we saw in the previous slide, the other 6 of them, because they are actually fairly wide. They're not compact enough. They can't land anywhere. And but the cost will come down significantly because they are electric, right? They're all electric. They're all VTOLs. They're all eVTOLs. Whereas with the E-plane that we are actually looking at, we expect to actually do what's called as true flying, which means that the plane comes to where you are. Let's say you are in an apartment complex. You will have the plane actually landing in the apartment complex, either in front of the building or on the rooftop of the building, and then take you to an office building where you have again a landing facility, because the 4 meter by 4 meter wingspan essentially means that you will land only within about a 6 meter by 6 meter area that's about 360 square feet approximately. That's quite small. It's like about less than about a single single bedroom apartment. So that kind of spaces are easily available on the roofs of most buildings. So we expect that a 12-minute ride is what you will take when compared to a 60-minute ride, and for the same price as a Uber Black, right? So and that's what we eventually want to do: take off at your home and land at your destination. And of course, we can convert these prices to rupees in the Indian situation. And what you will find is that when compared to Uber, so we'll probably charge at Uber Premium, which is about 1.5 times your Uber, the normal Uber fare or something. That's what I said to the beginning. So how is it possible for us to actually get a compact aircraft to fly slowly is really the question. So what we have done is to essentially take inspiration from what NASA had developed called distributed electric propulsion. And this is the implementation that a lot of other people like Joby Aviation, Lilium, Wisk, and maybe not Wisk, but Archer, they are trying to do. And that is what I call as like a second generation aircraft, because NASA essentially tried this for only a conventional horizontal takeoff and landing aircraft, not for a VTOL aircraft. So what they did was they actually took a plane, with a conventional plane, which has a single big propeller at the nose, and that's a very common plane that you would have come across, which is a 4-seater, let us say, like a Cessna or something like that. And they actually removed that propeller. So the first generation would be to keep the propeller, remove the engine, the combustion engine that powers the propeller, and the fuel tank, and then replace the fuel tank and the engine by a battery and motor. And then you have an electric version. So that's actually more like a first generation plane. The second generation is what NASA pioneered, which is to do distributed electric propulsion. So what they did was, when they removed that single propeller at the nose, they actually replaced it with a distributed set of smaller propellers, which are much less noisier. And they have small motors that are powering each of these propellers, right? And they are positioned in front of the wing. And why they position in front of the wing is because the airflow from the propeller over the wing allows for the wing to generate a lot of lift. And since you need only so much amount of lift to balance the weight of the aircraft, you can allow for actually reducing the wing area. So the way they had actually reduced the wing area was to make the wing chord lesser, or make it essentially very sleeker. So you can actually see this, the wing is almost like a rod. It's not even, it's not like the kind of width that you would normally get to see. right? So this essentially means that the drag over the wing substantially reduces, and that's very, very important for electric aircraft to extend your range, because batteries are not very highly energy dense. So you have to do all it takes to reduce the drag and increase the lift, or basically increase the lift to drag ratio. And that's what NASA essentially ended up doing, and that's what all the other people have attempted as well. But what we are trying to do is to see how to actually implement this in a vertical takeoff and landing scenario, in which you have a lot of vertical rotors. Now, what happens with these vertical rotors is they help take off vertically, and during that time they are essentially balancing the entire weight of the aircraft. But when you now go forward, you have the wings generating lift and balancing the weight of the aircraft. So you don't need this vertical rotors to balance the aircraft anymore, right? But that essentially means that they become like a dead weight. And you have to carry this dead weight all the way till the end, because takeoff is mandatory, optional, but landing is mandatory, right? So you want to land, so you want to carry these vertical rotors. Now let's say the other guys have actually said, okay, then let's actually tilt these rotors so that we can actually use them. The problem with that is when you now go forward with the wings, the power that is actually required from your engines is only to overcome the aerodynamic drag. And the drag is usually about 1/10 of the weight of the aircraft, because weight of the aircraft is essentially what's balanced by the lift, and the lift to drag ratio is definitely about 10. So the drag is about 1/10 of the weight of the aircraft. So what was actually used to balance the entire weight of the aircraft during vertical takeoff, if you now try to tilt all of that stuff, you don't require all of them to be operational during the horizontal flight. You need only 1/10 of that to be operational. So again, you're actually carrying a lot of dead weight. So and then you're also having this additional complexity that you're tilting and all of that, right? So there's like a failure mode there, and the aviation regulator will not certify it, and so on. So what we said was, let's actually use these vertical rotors in some way that will actually make sure that the wing is made compact. So what we have done is to take an inspiration from NASA DEP for the horizontal rotors. So we do the same thing with the vertical rotors, and get the wing to generate a lot of lift. But we need only so much lift to balance the weight of the aircraft, so we can try to make the wing smaller. So unlike NASA, where they put it along the length of the wing, therefore they can't actually decrease the length of the wing, they then may decrease the width of the wing. We are making the wing smaller by actually decreasing the width of the wing and making the plane much more compact so that it can land and take off in very, very small spaces. And that's how we are able to achieve so essentially it's a high lift wing. And since it's a high lift wing, we can afford to go slowly as well as make it more compact. And that is the patent filing that has happened with this. So where we are today is before the coronavirus problem that we had from last year, we had actually, let me see if I can play this. Sorry. Yeah. So we did make like a small plane that had these VTOL as well as forward rotors. So it actually climbs up vertically, and then over time it will actually find that the horizontal rotors also start turning and you can go forward. And you can see the specific design that we have, where you have like more like two wings, right? And so here we are actually having the horizontal rotors operate, and the vertical rotors are powering down and so on. So that is the flight. So this is what we had actually done. This is a very small aircraft which is capable of carrying between 2 to 6 kgs payload and about 1.4 meter wingspan. What we are currently up to is to design the second phase aircraft, which is a subscale prototype that is capable of carrying up to 50 kg payload. And we have completed the detailed design of this, and we expect to start fabrication soon. We have started ordering parts, and we have started receiving those as well. So once all these parts come together, we will start putting them together, assemble, fabricate the wings, the aircraft structure, and so on. So hopefully by July this year, we will have a flight of this and flight testing. The last one is actually the phase 3, which we expect to complete by next January, or maximum by March, because I'm already beginning to expect the third wave, unfortunately. so that these things would delay things in a very unexpected manner. And therefore, we expect that the full-scale version, which is a two-seater piloted version, should take off. The first prototype should be done and take off sometime in the Jan-March timeframe next year. So that's exactly how we want to go about it. Now, there is also a cargo version that we can do, because instead of a passenger, we can have a 120 kg cargo, which can actually get certification through next year if we start from January onwards, and so on. The further certification of passenger aircraft will take another 2 years. So not another 2 years, starting from next year, right? So by about April to June 2024, we could probably expect, mid 2024, we can expect the passenger aircraft to be ready for commercialization. And ultimately, autonomous will require a lot more certification, new laws to be enacted, and all of that stuff to permit this. So that we expect will happen only about 5 years later. So that's what is the roadmap on this. The market analysis that we have is that we will be pricing this plane at around the 1.5 crores, which is quite cheaper, less than half the price of the cheapest helicopter that is available in the market. And most of the reason why that this is possible is because of the development out of India. And as I said in the previous slide, about mid 2024, this should be available for commercialization. So we expect that initially it's kind of like how smartphones happen, right? So, or smartphones or even mobile phones itself. So in the early part of the century, around the early 2000s, not many people actually had mobile phones, and pretty soon everybody started having mobile phones, and then only a few people started having smartphones, and now everybody has smartphones. So likewise, we expect that only a few people will be owning these. So for example, if you now look at the Uber Ola situation, the cars are already available. The drivers come with the cars. So the Uber and Ola actually are not developing these cars. Whereas in the current situation, we have to make these planes. So who will actually have these planes are like these high net worth individuals and so on. So progressively, as the price point becomes affordable and so on, you will have more people owning them. And that's okay, because even if you have like about 10 planes, that can offer a credible service in a city, because these planes will actually take only 5 to 10 minutes for each travel when compared to about an hour and a half that taxis take. So taxis are actually almost like sitting on the road for so long for just one trip to be made. Whereas since these trips can be made very fast, we can easily do about 3 trips an hour. Like even if you assume it takes 20 minutes for people to get in and get out and all the stuff. Right, so you can easily do about let's say 5 hours worth of such trips, and then you have to charge for about an hour, and then again for 5 more hours of such trips, and then charge and 5 more. So you can easily do about 15 to 17 hours in which you will probably charge for about 2 hours in between. And one plane can actually easily clock like about hundreds of trips. And 10 such planes will actually do a good number of trips a day. So even if you had like about 10 high net worth individuals who bought like one plane each, and then allowed for them to be used as Uber Ola over time, after that trip is completed in the day, instead of actually getting this plane parked. That's a basic model of Uber and Ola. We will actually have a credible service. So it's not very difficult to imagine that the service will. And then initially at that level of very small number of planes that are flying across, current helicopter laws are good enough. So this whole thing can actually get underway with limited number of planes as we get into 2024, 2025 timeframe. Whereas if we then think further and further and the skies get crowded, there are people who are willing to there are like bank loans that are all possible for making these planes and then paying them back. Those kinds of business models happen. Then we will probably have to have some autonomous air traffic control that is beyond what the current helicopter operations are. And there are a lot of countries and cities that are actually working on those kinds of models. In India too, we will expect to initiate those kinds of things soon. So at that time, we will actually get like autonomous ATCs. We have to look at what are the safety requirements and all this. So that time we will actually get more helicopter taxi companies that will replace current helicopter fleets, and we'll also expect airlines to get into this business because it's essentially the same as airlines itself. So that's why we will expect by about 2025 or so, we will actually get this taxi service to happen, fairly similar prices to Uber, but 10x faster. Initially, it could be like airport shuttles. The airports could actually start offering these kind of services, and then a work commute, taking people from exactly one place to the other, and that kind of thing. And cargo is also another option which can kick in by late 2022, early 2023, that kind of thing. But these will be in what's called green zones of airspace, where you don't have too much human population. It could be like offshore oil rigs, oil and gas rigs, and so on, or medicinal supplies like vaccines, organs, and medical supplies, blood packets, air ambulance, all of those kinds of things. Right. So that's kind of market we expect that this will enable. I think this is the last slide, so I can probably stop very soon. So what is the possibility of these planes kind of getting certified? So one thing is, first of all, European Air Safety Authority, EASA, has already certified the first electric plane last year called Pipistrel Electra, which is a Slovenian company, Pipistrel, that is put out there. That's a first generation plane. So it's like it's a two-seater conventional takeoff and landing, horizontal takeoff and landing. They have replaced one large propeller worth of engine and fuel tanks with battery and motor, and we still have that full that front propeller. So that's what they have they're certified. But they've also now working closely with Volocopter and so on. They have developed standards for eVTOL certification. So that means like all you have to do is to follow those standards and get the certification done. So that certification process is well laid out right now. So particularly if you don't have any tilt, or you're not actually having an autonomous flight, you can easily go through the certification process just simply following what the standards requirements are. We have seen helicopters fly over the skies. NSOPs are permitted non-scheduled operations. There is a standard operating procedure for it, tying up with the attack, the ATC in the city, and so on. So the initial operations can easily be done with the helicopter laws. The current norms for helicopters operations will actually apply to these eVTOLs. So fundamentally, our development does not require any new laws for certification or operation. So you just have to go through the certification process and put in place the operational norms that are existing into the practice. That's it. So the key highlights of what we are doing here is this is actually the most economical development coming out of India. Very similar to the ISRO story, right? So going to Mars in a at cost that's much less than a Hollywood movie takes, right? That kind of same the frugality out of Indian tech is essentially what we bring in. We have a team which has been put together, which cumulatively adds up to about 80 plus years of aerospace experience. There are people with about 9 to 11 years experience working in planes like Airbus directly. And that's simply because India is actually home to all the aerospace majors R&D tech centers, primarily in Bangalore. So be it whether Boeing or Airbus or many of these engine makers like GE, Pratt & Whitney, Rolls-Royce, Safran, which is with SNECMA engines, and so on. All of these people actually have their R&D centers here. So and then we also have DRDO, which has been making the LCA, and now they are actually looking at the AMCA. We have the GTRE, which has been making gas turbine engines. We have HAL, which has made a whole bunch of very good helicopters. So there is like a lot of experience that's available within the country. And we have been fortunate to tap a few of those. Our team is still very, very small. It's we are about 19 people together, including the founding team, like myself. We, as I explained, we have a fastest certification and go-to-market strategy for commercialization. And we have actually looked at what is the most suitable technology that's required for urban aerial mobility. We have targeted that kind of an aircraft to be built for that purpose. The slow-moving and the compact aircraft kind of thing. It has a very large total addressable market that goes into like billions of dollars globally. So this is a big industry that's expected to take off very soon, literally. It's an R&D that's coming out of IIT Madras, which is India's #1 technical university, consecutively for about 5 years now. And I think pretty soon we'll also get the latest rankings for this, the NIRF rankings. So thank you very much. If you have any questions, I'll be happy to answer.
Thank you very much, sir, for such an insightful talk. And I'm sure all of us are excited to see the air taxis which you are working on, that your dream should materialize as soon as possible. And we'll be happy to sit in one of those air taxis and travel. Thank you so much. So the session is now open for questions. So we would like to take up questions from the audience from Zoom platform as well as YouTube platform. So let me read. Okay, so there is a question from Mr. Chetan Hansraj. He's asking, is it safe for air taxis to travel over buildings in case of engine failure or accident in the sky?
Yeah, I think that was the first point that I made in one of the early slides, which is to say that we will actually have multiple small rotors instead of one large rotor that helicopter has. So in the case of helicopters, there are special requirements called twin engine helicopter operations for like elevated platform takeoff or night operations and so on, so that there is like some amount of redundancy. Whereas here you'll have an inbuilt redundancy with large number of rotors. So even if like one or two rotors fail, you'll still have the other rotors take it up. So that is number one. Second, we also have the wings that actually generate the lift. So even if the entire rotor system shuts down, we want to actually glide to safety rather than fall like a brick. So either way, I mean, the quick answer actually I should give you is, if you have seen helicopters fly over buildings and didn't feel unsafe, there is really about 10 times less reasons why you should actually feel unsafe with these. That's a quick answer.
Okay, so the next question is again from YouTube side, Mr. Mahadev Lokhande. His question is, what is typical safe distance separation between two landing stations for such innovative air taxis?
So I don't think we have actually come to the point where we will, I mean, even if there, let's say, for example, you have like two adjacent buildings, right? Two adjacent tall buildings, like two blocks of an apartment complex, which are, each of them is like about 20 stories or something. Each of them can actually have a landing pad at the terrace, right? The question that you have to ask is, can two aircraft simultaneously take off, right, or land? So that is the real thing, and not whether the proximity can be, close enough. So, so we have to actually evolve regulations on that. Today, for example, if you look at aircraft, there is a minimum distance on the runway between like one aircraft taking off, the next aircraft taking off, that they have to worry about. So the regulations have to actually come in place for what should be the time gap between planes that are taking off in close proximity. But proximity itself is not a physical distance. Proximity itself is not a limitation.
Okay, so the next question is from Mr. Amritanshu Vajpayee. He's asking, are city residents ready for the potential noise impact from low-flying air taxis?
Okay, you're making a lot of assumptions. I don't know. We never said that there's low-flying air taxis, right? So there will be an altitude corridor for this that's actually significantly higher, something of the order of about 0.5 kilometer to 1 kilometer. So that is number one point. Second is, I actually specifically made this point again, that it is going to be much less noisier when compared to helicopters, because we have these multiple small rotors that actually turn at very high RPMs, and these RPMs will actually emit noise that the human ear is actually extremely less sensitive to. And you'll also have ducts that are shrouding these rotors. Therefore, the noise is actually going to be very, very less. And if you're actually asking if city residents are ready, please ask them rather than me. Okay, that's just a joke.
Okay, sir, I have like two questions. One is, what about from air ambulance perspective? How you're looking at converting air taxis into emergency air ambulance service, and how good these air taxis for near seashore operations?
Good. I think there are two different and separate questions. At the moment, actually, we have essentially two seats, right? So we have a pilot and another seat, and the seat, of course, will be actually as reclining as it can get, like in a car. right? So we would probably have patients that have to be physically transferred from a stretcher onto the seat, and then the seat has to be made to be reclining as much as possible, and so on. And you can then have contraptions that are there, like for example, an oxygen mask, an oxygen cylinder, and maybe a saline, any intravenous thing, and so on. So, but it's that will actually mean that we need to have the paramedic also get trained to pilot the aircraft. So that is the current implementation that I can think of. Over a period of time, we could actually try to make this better, simply because batteries will actually become better. So if I'm able, and then the second point, even today, for example, right? So it's not as if like the air ambulance is actually going to do like a run like an air taxi, right? Unless we are in a COVID kind of situation, right? A typical kind of situation, you don't really expect ambulances to be running so busy, particularly when you're able to make these trips within about 5-10 minutes, right? So today ambulances are actually busy because they take like a very long time to go. The ambulance is actually on the road most of the time, right? Wasting its time. So by the time they actually get there, they will be sent on another trip and stuff, right? Whereas this is not the case with an air ambulance. So what it essentially means is that I don't have to have the 200-kilometer kind of distance range. I can try to make it only about 50 kilometers or 100 kilometers, which means that I can shave off a lot of battery and then put another seat, right? So that I can actually have an extra paramedic, so that will take care of the patient, or I could also have like a stretcher that can be built into this, and so on. So those are all something that can be made even in the present capacity. If I actually were to extend this a little bit more and make it like a 4-seater equivalent, then it'd be a lot more easier, but it doesn't have to be so compact. Then it can probably have to be 5 meter by 5 meter. Hospitals will have to have these larger spaces and so on, but getting them to land near where the patient is going to be difficult. So I think the compactness is still has to be maintained, is what I would think. And therefore, I think shaving off batteries and making more room for an extra paramedic or a stretcher to get in, don't think that is doable even with the existing kind of form factor. Yeah, that is the air ambulance question. The second question, as far as seashore and so on is concerned, is essentially windy conditions. So there actually we have a very good news for you. So the implementation that we are doing when compared to everybody else is actually very, very interesting, because we are keeping the vertical rotors vertical and operational. And that's how we are getting the wing to become compact. And this essentially means that, first of all, you have winds. Let's actually look at gust loading, right? That's what typically the rating is for. When you have very large wings is when the aircraft is much more gust prone, because you have a large surface area that is prone to the gust coming and slapping on it. So our wings are very compact in the first place, so it is less gust sensitive in the first place. Second, we have these vertical rotors operational, which means that just like how a drone is controlled with vertical rotors increasing and decreasing their speeds to balance, right? In addition to the control surfaces that we have, the ailerons, elevator, and rudder, that is what actually usually controls the aircraft when you have gusts and so on. So we have like two layers of control. So if you now combine these two controls, we have like a much more robust control that is possible for overcoming gusts and very windy conditions. So we expect that our aircraft will actually fare much better against gusts than any other plane in the world, and that's by design. So the control law is actually what we need to validate under those conditions, but that has to be something that we do progressively more and more over time, instead of immediately jumping in and trying to face like very, very high winds. So the potential is there, the theory is there, practice will take time, but we are very confident that we can do it because of of the capability of the design itself.
Right. Thank you.
Professor Satya, I have 2 questions.
Yeah.
Suppose if we go to the hilly region like Jammu and
Right.
Kashmir area, and there is a snowfall.
Yeah.
We take off from the ground and suddenly the snowfall starts.
Yeah.
So can those loads of the snow loads it can take care?
We don't have. I don't have an answer to snowfall. In fact, we have one big disappointment that you will get is helicopters today cannot operate even if it drizzles, as in just normal rain, right? So helicopters have those kinds of huge limitations. So we want to actually see what exactly is the reason why that is that is the case, and see if we can overcome that. So my first question will be, will I be allowed to actually take off at rains simply? Forget about even snow, right? And I don't have a direct answer to that because it's a regulatory problem rather than a technological problem.
Okay. Question number 2 is, so in normal case, suppose there are 4 rotors, and out of 4 rotors, 1 rotor gets jammed, it fails, or 2 rotor fails. So what will happen to the vehicle?
We have actually, in fact, I think most of these planes that I showed, including ours, has something like about 8 rotors. It's actually a very large number. So of 8 rotors, we don't expect 4 rotors to get jammed or fail. Maybe 2, 3 will do. So we will actually have to go through a failure mode analysis of each rotor failing or combinations of rotors failing. What's the probability of that? And what will be the controls? So because you have these wings and then you have these elevators and stuff, right? So we can actually deploy them constantly to overcome the rotor failure and so on. So that's possible. During takeoff, this is actually a standard problem with drones. So drones face this problem. So
suppose all the rotors fails, can it glide like a glider?
That's because we have the wings. It can actually.
You have the wings.
Yeah.
Okay.
Since it is not a low flying, as you are saying, there is few gliders. They have a parachutes on it, as in safety. So how about including?
Yeah, I mean, it's not only parachutes, but we will actually come up with other means of safety, like so that it lands with a cushion, and so on. So we will want to make sure that this is like ultra safe when compared to any other plane that you have seen.
And I have one more question about the airlines. The technology has worked on an autopilot in most of the cases, as we see at the current times. So how about in initially phases operating this in autopilot?
Oh no, actually, so the answer to that question is this, right? So autopilot essentially means that you indicate a origin destination pair with what's called as waypoints, and then the autopilot essentially does what's called as waypoint navigation and a path planning based on that, and it will automatically actually follow that particular flight path. All right. So or a pre-approved, pre-authorized flight path by the ATC based on those waypoints. This is what it does. The pilot is sitting there to see if there is any obstacles that are going to come in, and then inform the ATC about it, and then take an alternate path, and then get back to the originally authorized flight path and so on. What we actually do is we have lots of sensors on board, that like an autonomous craft or an autonomous drone, autonomous vehicle, which will sense obstacles that are coming up, and then inform the control system itself to actually take these deviant maneuvers and come back to the original flight path. And that is actually the fully autonomous flight that we're talking about, right? Since we have to have a pilot because of certification reasons, this will actually become more like a obstacle alert. Like today, for example, you have these cars, when you now try to take a reverse, there is a camera there that is actually showing you a picture and then also giving alerts in terms of sounds and maybe voice and stuff, right? So we will have a pilot assist system that actually informs about obstacles in addition to doing this autonomous flight. So all of that stuff is actually, we can actually say taken for granted today. So we will all these systems will be there in our plane anyway.
Okay.
I have 2 questions, and it is related to scalability. Suppose, and it's general. So suppose this technology comes to pass, like it becomes like cars, how cars are today. My first question is that we in a city are limited by how far we can travel, and that is at least in Mumbai determined by how far the train goes. So if we get this kind of a vehicle which has a range of 200 kilometers, would it have potential on the way the city is planned? 1, and 2, if a lot of these machines are operating, and how would one think of addressing them, impact it would have on the environment in general? Because then you would probably have to think about traffic and different zones in the sky and in 3D actually. So how would you address this?
So the point is, first of all, we have a very skewed idea about how road transportation actually has been happening, because we have not been starting with Uber and Ola kind of thing right in the beginning. Okay, so the car actually is actually the most useless product ever made, because it is used only for about 4% of the time. 96% of the time it's always in the parking lot, right? Until Uber, Ola kind of thing came. All right. So the sheer number of cars, and that's how they wanted it. The automobile companies wanted to a lot of sales, right? So they wanted to have a lot of cars, first of all. But Uber Ola does not actually change the number of cars on the road. It's just that they don't get parked. Right? On the road, congestion is still the same, regardless of whether you have Uber Ola or ownership. So the first point I want to make is that ownership of cars essentially is the one that gives an idea that there are a large number of cars. But the congestion is actually what really strikes the eye in terms of number of cars on the road. That will be the same even with Uber Ola, right? Now you have to think about planes. Because these planes can actually do trips that are very, very fast when compared to a single trip that a car can do. You don't need as many planes as the number of cars that are on the road to actually do the same number of trips. So the number of planes in the sky that will, let's say, for example, all cars are replaced by planes, right? So you don't have any cars on the road and you'll always have only planes. The planes will actually be far fewer by a factor of about 10, right? Because you will take like 10 times less time to get from point A to point, right? So that way you will actually have a very, very less number of planes in the sky when compared to on the road and the total ownership and so on. The last point is the air is actually three-dimensional, right? So if I'm actually on the road, I have to actually follow one car one car behind the other, right? If I'm in the sky, I can actually have one plane fly above the other with a certain separation. And that corridor that you have vertically is actually very huge, right? So you can go anywhere from like what, half a kilometer to 1 kilometer or 1.5 kilometers, that kind of heights. So even with considerable spacings, we can actually have crisscrossing of these planes at different altitudes. So if you get to the point where, if you can imagine that all cars are replaced by planes, you will still have like a nice quiet traffic corridors that are now well laid out, saying that if you're going from point A to point B, you will have a computer generated algorithm that will now say this is the flight path and it's not going to actually intersect with any other flight path that is around right now and so on. All of these things will have to actually be orchestrated in like some blockchain manner or something like that. So all these things are actually being thought about, by the way, right? But we are not going to get anywhere close to that anytime soon.
And the part about the environment regarding the scale.
Sorry.
The part about the environment impact on.
All these are electric, so there is absolutely no emission, no carbon, footprint, nothing, right? So question is like, how do you generate electricity? So you have rooftop solar or solar and wind renewables. Those things will have to take care of making sure that we are definitely there's not going to be any pollution.
Even the noise factors also.
Yeah, the noise factor, I think we addressed in a previous question. So it's going to be much quieter.
Thank you, sir.
So I think most of the questions we have answered, and with that, I thank Professor Chakravarti for taking out his valuable time and sparing his time with us and enlightening us about the future of air taxis in India. And we wish him all the best in his endeavor to make this dream into reality immediately in near future. Thank you, sir.
Thank you for calling me to the good stuff. Thanks.
Well, thank you very much, Professor.
Thank you, sir. Thank you. Thank you very much.
But Dr. Dharmendra has joined.
Yes, I have that.
Yeah, welcome, sir.
Thank you. Am I audible?
Yes.
Yes. So good afternoon, everyone. So here we are at the last session of our 4th day of Advanced Technologies webinar, and we are fortunate to have Professor Dharmendra Singh, who will be enlightening us on the topic of the smart drones, and I am here to introduce him. Professor Dharmendra Singh was born in Varanasi, UP, India, and he basically belongs to Jaunpur, UP, India. He received his PhD degree in the electronics engineering from Indian Institute of Technology, which is earlier known as Banaras Hindu University, Varanasi, UP, India. He's senior member of IEEE. He has more than 27 years of experience of teaching and research. He received various fellowships and awards by the national and international bodies, mainly Monbusho Fellowship, Japan, UCAR Fellowship, USA, Merit Fellowship, European Union, DART Fellowship, Germany, TWAS Fellowship, China, IFCAM Fellowship, France, TWAS Fellowship, Brazil, and many others. He has worked as a visiting scientist postdoc fellow at Information Engineering Department, Niigata University, Japan, German Aerospace Center, Germany, Institute for National Research in Informatics and Automatic, France, Institute of Remote Sensing Application, Beijing, Karlsruhe University, Germany, UPC Barcelona, and visited several other laboratories in the countries. He received Best Innovation Award in India Mobile Congress 2017 for development of satellite-based agricultural information system. He has received the Best Industrial Research Award 2017 by Institution of Engineers, Turkey chapter. He has also received Dr. Ajit Singhvi Institute Chair Professors in June 2018. He received National Gold Award for e-governance in the year 2019-2020 for outstanding research on citizen-centric services for the project Satellite-Based Agriculture Information System, an efficient application of ICT by the Government of India, Department of Administrative Reforms and Public Grievances. Currently, he is working as head of the Department of Computer Science and Engineering at the Indian Institute of Technology, Roorkee, and professor in Electronics and Communication Engineering Department. He is also the coordinator of Drone Research Center and coordinator of Common Research Technology Development Hub. He has started a startup, Dheer Ghadi Technology Private Limited. He has guided 30 PhD students and 20 are pursuing their PhD and guided more than 66 MTech students. He has published more than 325 research papers in reputed international national journals and conferences. He has developed several products. His main research interests involve ICT applications, artificial intelligence, computer vision, deep learning, machine learning, data fusion, satellite data application, polarimetric and interferometric application of microwave data, microwave imaging, drone-based applications, numerical modeling, radar-absorbing materials, and stealth applications. With that, I invite Professor Dharmendra Singh to start his talk. Over to you, sir.
Okay, thank you very much, and thanks to Dr. Mathur for inviting me in such a good webinar session. And I am just going to share my slide. Is it visible?
Yes.
So when I was discussing about the Dr. Mathur, then I thought that it is a good time because nowadays drone is taking a lot of focus for different applications. There are three aspects for the drone. Once we are talking the manufacturing of the drone, second one people are talking nowadays entry drone, stealth drone, and third one is the drone based application, how efficiently we can use the drone for different applications. So and as I am also the coordinator of the Drone Research Center. So we are basically we have done a lot of work, and we are doing for the drone based applications. We used to give the customized solution for different agencies, as well as we have started stealth drone, and we have started to work for the anti-drone technology also. And because due to the pandemic, we are in process to start some customized drone, full drone with the manufacturing and all other things. So these are the three main aspects for that Drone Research Center IIT Roorkee has put. And we are trying that how we can contribute to the country to become Atmanirbhar Bharat and whatever. So today I thought that because everybody is knowing drone. Drone is just a carrier. So how we can cleverly, and it is very true because I am a teacher. So it is very true, means some facts we must have to know that before telling to the truth to the other. So as we are saying that everybody drone. So, and I am not going to question that manufacturing and all, that is a different aspect. But the cleverness is that how efficiently and the cost effectively. Another very important thing is the cost effectiveness. How efficiently and cost effectively we can use the drone. Because if you somebody say that, okay, for example, we want to monitor agriculture or health center or whatever is the thing. So everywhere you cannot fly the drone. So we should have some very smart solutions also. So where we can get the accuracy or where we can get the precision like a drone, but maybe from different sensors or whatever. So things should be very clear that, and basically I am working whatever be the solution. If you will go to my web page, this the startup also, the Dirghadi Technology Private Limited. I thought that now I will put the in Hindi also. People used to be difficult to understand. Dirgha means dur, Adhi means dekhna. So dur ka dekhna. Therefore, it will see that here. Uh, Here, this is the logo of the Dirghadi. This is the telescopic eye, where the some person can beyond the reach. If you want to see that, so you can see that the thing. So therefore, Dirghadi. So if you will see that, so I used to give the cost-effective solution. A lot of solutions are available here and there, so a lot of things are roaming around. But the beauty is that, as the Indian context, we have to provide a cost-effective solution. So I thought that today I will be discussing the means research, what we are doing for the drone applications, research-oriented work which we have done in our lab, and some basic philosophy or concept behind that, how we are trying to make it cost-effective solution. So as I have mentioned that everywhere we cannot fly the drone, so that is the thing. So variety of information, detection algorithms, outcomes, concluding remarks, questions, whatever we are looking. So once we are trying the drone, so there are two one very important application area is the defense area. So where whatever else, nowadays a lot of things we are listening that target identification, subsurface detection, motion detection, human detection, camouflage detection. So I will be showing you some of the area we are working, and we have some very good solutions, and we are trying that how we can use it. And second, for the civilian application. So if you will see the civilian application, then means as I have mentioned that this is not limited to this. Just it is a sum of them. Precision agriculture, surveying, fire, search, industrial, now health also, crowd monitoring, health sector, whatever we want. It is our cleverness, how cleverly and how cost effectively we are going to use it. So, and in which some of the applications I will be showing you in the next few slides. So once, as I have mentioned that drone is a carrier, and then the challenge starts, what kind of sensor we have to deploy on the drone. So we should have the different applications, different user-defined applications where user what do they want. For example, if target identification, for example, if surface detection. So what kind of sensor should be deployed on the drone? And what we have seen that now in the era of 2021, now the era is the multi-sensor data, because a lot of sensors are available. Therefore, the term came IoT, Internet of Things. So it doesn't mean that it means that you have a number of sensors. How cleverly, how smartly you are bringing all the information in one platform, and you are using them for the better application. So similarly, if this is the drone. So what kind of sensor should be there? So so different type of sensors has a different information. Then the always challenge the data fusion, how we can fuse the data and how we can get the data from the fused image or fused data, how we can get the required information. So optical view, object temperature, energy, backscatter, distance of the object, whatever reason. So infinite things are there and infinite type of sensors. So as I have very clearly mentioned in the first slide that the solution should be precise, accurate, and the cost effective. So therefore I have mentioned that what I am trying here, what I am showing here, what the expertise we have in our drone research center and what the expertise we have in our department and all other things. So that I am trying to explain that I am trying to discuss here what we are trying to do. So fusion. So as I have mentioned that I will show you some result of the fusion, very good result, and then whatever with the descriptions are there. So detection, identification, first application, detection, identification of various areas for precision monitoring. So you can see that this is the Google Earth image. So first, because pre-processing of the drone data is again very challenging. Still, I have not seen any open source code or something like that where we can mosaic the data, because things are coming in a number of images are coming, and how we can mosaic it, how we can make it one. That is again a very biggest challenge. So you can see that this is the if this is the so if this is the area, this is nearby. Whatever I am going to show you all the nearby Roorkee area only. So this is the Krishi Vigyan Kendra near to Roorkee, just 10 kilometers from here. And if you want to map the Roorkee, this Krishi Vigyan Kendra with the drone, then what the problem is that you can see that this is the flight direction and drone. You can see that this type of scenes we are getting, and the challenge is that how you are mosaicing that. So we have enough expertise because mosaicing, georeferencing, and geocoding one of the biggest challenge. So each by each pixel up to accuracy of plus minus 5 centimeter, you should have the same as per the actual land cover or something like that. You can see that very nicely. This is the we have a 2-3 drones here with different sensors. So this you can see that how accurately we have this one. This applications I will show you later on. So we have a better expertise, good expertise for doing all the pre-processing and all other things. Drone mountable sensors, generally people are using the HD camera, 4K nowadays. A lot of cameras are there, but sample of this high definition camera I have just shown you. But another camera we are saying that that is very useful. That is the multispectral camera. So multispectral camera has a different wavelength, and they are very used. For example, if we are saying that the agriculture applications, so how we can differentiate between the stress plant and healthy plant. If I am saying the precision, so for example, Roorkee is nearby Roorkee sugarcane fields are there, and in the sugarcane field is something like a 1 kilometer by 1 kilometer areas. Inside the field, some small gaps or something are there. So how we can use that? So therefore this is a multi-spectral imaging sensor. Post imaging, why drone are used for monitoring. So second example is the railway track health monitoring. You can see that I will show you some things for this also, some results for this also, because this is again very challenging task. A lot of railway, because what we have seen that the railway track inspection is by some cart is there, and with the cart people are trying to inspect their distance between the two tracks, their fist plate, a lot of 8 or 10 parameters are there. So how effectively, this is the nearby Roorkee only. and how effectively, I will show you some very good results which we have obtained and published also. So how we can, because a lot of places are inaccessible or very difficult to go there. So there, that place drone is a very good alternative where we can monitor the railway track and all other things. So replacement of this well suited for fast, efficient maintenance operation in case of this. So for example, sorry. So first example is that first, just 1 minute. Just 1 minute. So for the multi-sensor integration of airborne platform, so railway stationary and moving object, railway assets, man-made natural structures, object, railway track health. So first is the railway track health monitoring system. So first objective is that how we can railway board track components and the object detection. So asset nearby railway, how the drone can be helpful for the asset monitoring. So you can see that. So these are the different components. So that is a very interesting one. So we had started 2 years before. It was really very big challenge for all of us. This you can see that this is the joggle fish plate. How we can see this joggle fish plate from more than the 100 feet height or something like that. It is a very challenging. Now we have developed some solution to this one. How to measure the distance between this one up to accuracy. You can see that it is approximately 167 centimeters. So up to accuracy of 1 to 2 centimeter only there is a margin. So how to measure the accurate this one? Then basalt. You can see that this is the basalt. If you will see very carefully, then and cross tie, basalt. So this is the things. A lot of things are there. 8 components are there which used to be monitored. So we have got so you can see that there are different anchors, longitude leveling defects, gauze, cross label. So eight type of things are there which we have to monitor, and in which 4 or 5 things we are very accurately and nicely monitoring with the drone sensors. So various object detection methods. So sensor, we are using the 3 sensors nowadays. That is the thermal, multispectral, and HD camera. So there are different, as I have mentioned that maybe some students have also joined, so they have to know that what kind of technique, image processing, computer vision, pattern and recognition. So knowledge of all these things, because sensor will give a raw data and how to process, how to post-process this. That is, so there are 2 parts, pre-processing and post-processing. So how we are doing that, that is a very important aspect. So for this type of work, computer vision is one of the most important things. You can see that image acquisition, image pre-processing, image pre-processing, image processing, image enhancement and all, object-based image analysis segmentation, feature extraction, because as I have shown that we have 8 or 10 things to detect. So what are their features? That is a very, and then using the artificial and classification, detecting the accurate, as it is a basalt tie or it is a whatever the thing. So and in the asset monitoring, such as cement slabs, pipelines, transformers, wires, walls, this periodically limited amount of data in some places. In order to improve accuracy, the samples and their variability is increased. So you can see that. You can see that We have detected it. It is a power brick. It is a transformer. So we have, this is the nearby Roorkee only, what the data I am showing, all the data. So cement slabs, power bricks, transformers, so all the assets we very nicely we have developed with the artificial intelligence based technique. So racks, rocks, signboard, so all the assets we are detecting very easily. So this is the technique, that annotation tool using the deep learning annotation tools, and we have trained the data and we have done the thing. So this is the, you can see that this is the actual flow chart for drone image pre-processing, division of image into 6 parts, training with the YOLO, and then object detection, and then prediction of the target, what kind of target it is there. So it is a totally data-based, data-driven. Once we have a good data, level data, then we can do the thing. So this is the processing flow chart, how we are doing. Test result, again, very interesting thing. Once we are trying to do, because image is not knowing either it is a man or living or non-living or what kind of target is there. So so we have tested image with the person as a object. So you can see that all the object here, person, it is a raw image. So we have detected all the persons here, and nothing is detected, no false alarm is there. And similarly, in the second, you can see that there are some cement slabs, and we have detected very nicely some cement slabs. Here also one cement slab is there. So cement slab, and 2-3 slabs are there. So we have all. Then we have tested if both cement slabs and wire or some rocks are there. So how we can test it? So construction racks, rocks. So small rocks. You can see that a small rock. This is a very different from the cement slab. So we have enough expertise for using the artificial intelligence to the observation, false detection, misclassification. So these are the things. So again, we have tested. Now what we are trying that how to. This is the garbage. So how to monitor the garbage also. So and in an image, if we have the 3 different type of things. For example, you can see that this is a complex image. It is not the same. It is a transformer. It is a brick. It is a garbage. So how nicely your algorithm is working for the monitoring of all these things. Similar for here. And here you can see also. So what I am trying to show that if we are increasing the number of targets and number of different targets, then also we are capable. We have developed some technique where we are capable to detect all the different kind of targets through the drone based sensors. So, and then we have tested, there are 2 things that is a very interesting once we have flown the drone. That is the brightness effect. Either you are taking the data in the morning or in the noon or in the evening. So then we have developed technique where the either till evening, so going to be whatever the data you are taking, if you are flying, so that is independent with the brightness of the day. So here also you can see that it is the evening time, so we have detected all the things very nicely. So a lot of scopes are there where you can area estimation, number of classes, modification, change detection. So intrusion detection in asset tracking modeling. So that is the thing. So now the vision-based real track extraction and monitoring through drone imagery. So as I have mentioned that with the distance between the 2 tracks, detect and label the linear railway tracks from a given drone image, which track the distance between two tracks. So that is, as you have seen, that distance between the two tracks is 167 centimeters. And we have margin of plus minus 2 to 3 centimeters. So how we can monitor that one? So we have done this work with the DJI Phantom. So as I have mentioned that if it is a HD camera image, then the illumination and the brightness of the day is very important factor. And we have developed, it should work. You can see that it should work the weather conditions such as illumination and fog also. So noise removal, crop resizing, so all the pre-processing things. So at what, the result should be the time independent. It is not like that if it is the evening, then result will not come, or if it is the morning, whatever is the thing. So just I am saying that, so we have done the color method, so changing the different colors. And then we have detected the edge. You can see that how nicely using the edge detection technique, how nicely we have detected the track. But if you will see, that is a big challenge is the distance between how you are going to measure the distance, because our aim is to first detect the track and then after that measure the distance between the two tracks. So we have developed this, what is the exact GSD, that is the ground sample distance. So that is very important. And then we have changed whatever be the area or that is the pixel size to the GSD, and we have calculated the GOD is equal to GSD into number of pixels count, because we are counting how many number of pixels, if it is a 10 megapixel camera or it is a 12 megapixel camera or whatever it is. So we have done this process. So already find region of interest, convert image to grayscale, any edge detection, track the edges, then the error detection, gauge measurement, error detection, and then we have to, because it is a frame by frame, so one frame is something like 50 meter by 50 meters. So, and then move to the next frame and then see that. You can see that this is the result which we have achieved. You can see that how nicely it is approximately 162, 163. And this is the number of pixels, means track length across the track. So it is a plus minus 5% under the permissible limit. We are able to detect that. So error is, you can see that error is, so at different altitude, because some places you have to fly very high because due to the some reason, some practical local problem of the area. So we have seen that if it is altitude 275 meters, 382, 380, what kind of error is there. And you can see that whatever the error is less than 1 centimeter or something. So all the things we have developed automatically. You have to just get the image and automatically you will get the result for all. So this is Vertice. So this we have developed for this one. And as I have mentioned that for the different illusion, for the fog or the weather, for making it weather independent, we have, you can see that here, presence of poles beside the railway line. Then we have taken the complex structure, presence of poles, oil line between the railway lines, railroad track, area of illumination irregularity. You can see that here it is a very bright and here it is a very less bright. Train running over railway track and catenary challenges are there. So because in image is just a image thing, and it is our responsibility to how smartly and how effectively we are taking the information. So you can see that 1, 2, 3, 4, 5, 6, 7, 8 challenges are there. How to develop such an algorithm which can detect the track as well as it can measure the distance between the two. So we have developed for this. So you can see that the different analysis we have done, what kind of changes we are observing, if different type of objects are there, and then we have designed our own algorithm, page map creation, candidate railway line detection, hop transform, GST based linear selection, coordinate system transformation based the railway track, and then so you can see that for the all the complex scenario, we have extracted the railway track, and you can see that very nicely, because the wire is a very this wire is a very once we are doing, and you can see that some small parts are also there, some different types. So that are challenging, and then we have eliminated, and we have done. You can see this image. This is a very interesting, very complex image. You can see that how nicely it is detecting the. You can see that this how nicely our algorithm is detecting that thing. So this is the wire. This is the thing. So what I am trying to say that we have applied our algorithm more than 1,000 images and tested, validated, whatever we have. So and then we are able to detect in a different complex scenario also the railway track and the. Then again, this challenge just now 2 months before we are able to do something for that, because seeing this is a very challenging, and we have developed some algorithm focus on automated detection of joggle plate, implementation of automated vision-based technique. So study area, as I mentioned, that all the images we have taken near the Roorkee only, and then we have proposed a model based on the computer vision and optimization, and then we have putting. You can see that green faceplate, bounding box, blue bounding box, red bounding box. So here we were getting a lot of false alarm. So I am just going to show you you can see that it takes more than 1.5 years to solve this problem, approx 2 years. So you can see that here we are not able to see anything, but here you can see that this is the display by seeing the image, by making the label data and doing all the things. It is really so. So she is my student, animation tool interface, and for the different possibility for the different location, and then template based feature matching we have done, and then we found that there is some possibility where we can get all the things. So different features we have calculated, different templates we have matched, and then we have find out how we can obtain the display. So first our aim was no need to go for the false alarm. First we have to detect either there is a capability of detecting or not. And after once we are able to detect, then we will see that how to reduce the false alarm. There are two possibilities of the false alarm. One is the false positive and one is the false negative. False positive means the target is not there, but we are detecting, and false negative means target is displayed is there, but we are not detecting. So you can see that. So there are several false alarms are there, but we are able to detect that. That is the beauty of that. Our algorithm is able to detect so small things. So this blue is the actual detected one, red one is the false alarm, and D1, D2 is the green, which is a false negative. So then we have developed the deep neural network based. We have just improved that one. How, as I mentioned that now we have seen that yes, with the drone based sensor, we are able to detect this small target. So how to introduce how to minimize the false alarm. So we have done the reduction of false alarm. So we have done. You can see that this is the actual fish plate location, and correctly predicted location. So we have done, and then here there is a minimum false alarm. So, but in another scenario, once because railway structure is a very complex one. So this is one of the most complex things. So correctly predicted, but there are some false predictions also. So just now, because last result I have not entered there, but just now we got a very good result that now we are detecting the very good. So what I am trying to say till here, that is we have successfully developed a technique where we can detect the very, very small target in a very complex environment. So that is the that we have developed in our lab here. Second, as I have mentioned that how effectively there's a because people nowadays are working a lot of for agriculture. So how efficiently we can use the drone for precision agriculture. Another very important thing, once I am saying the precision agriculture means inside that, if it is a very big field, inside that what is there, how we can detect. But again, challenge is there. All over India, you cannot fly the drone. So how you can use some advanced technique like fusion technique. So use some drone data as a reference and then make some fusion technique. And then you can get with some another data. Another data means some satellite-based data. So that is easily available, but and their temporal frequency, because once we are saying the agriculture monitoring, it means their temporal resolution should be very good. Either the daily data or at least 2-3 days data should be there. So that is the important thing. You can see that this is the satellite, and if we are getting, you can see that this is the drone data. The sample I have shown, not actual one. This is the drone data high resolution, and this is the low resolution. And once we are fusing, you can get how nicely the fused data we are getting. So it means fusion has a good potential. And if we are using that with the satellite, I will show you, we got a very good result and we published a very good paper and we are working on that. So, and this is the Roorkee region. This black line, what you are seeing, this is the Gun Canal. And this is the canal, and this is the one of the best canal of the world. It is approximately 817 kilometers long, running from Haridwar to the Allahabad. And a lot of stories is there. Therefore, for this purpose, making this canal, only the IIT Roorkee came in the picture, means Thompson College, and after that IIT Roorkee came in the picture. So different algorithms, you can see that, and then I will show you the results of that one. And then the another very important task of the drone, you can see that this is the drone image. And once we are trying to count it, how many persons are playing in this one. So we have developed algorithm. And by seeing that, you can see that. And for this, we got the, in 2019 hackathon, Uttarakhand National Hackathon on the drone, our student got the first prize for that. So you can see that how nicely everything is detected. And now once you have detected, you can count it. In a color segmentation, if a person is hiding under the tree or something like that, so how we can detect with the drone. Then number of rows, how we can calculate. We have developed the technique. So we can count the rows. You can see that very nicely. We are able to count how many rows and how many things are there. So then nowadays drones are very useful for the construction site survey. So you can measure what are the assets are there, what are the things are there. So what are the how many areas he has covered, whatever be the thing. Very precisely you can estimate the area and all of that. You can see that 3D model view. So this is the inside the IIT Roorkee campus. Now when we went for, this is the car, my car, and this is the taxi where we went for the near to the for the survey, and with the drone image, how we are able to detect. You can see that very nicely we have detected the target from the drone image. And if it is the camouflage identification, if it is the camouflage type of target, then also we have developed the technique. For example, you can see that if it is something like that, mixing like this one, so we are able to detect. We have developed the technique, reworking, and then you can very easily you can detect what are the difference of this. So now I am coming to the last part of this for the agriculture application. So that is the precision agriculture, as I have mentioned that India is an agriculture country, and then we should have to know that, because it is, you can see that it is only, this area is only 0.23 square kilometer. And I will show you some very good results. Inside that, there are 50-50 meter patch or 20-20 meter patches where the crop growth is not as the crop growth is not as good as required. So how to monitor and then how to do that. So you can see that this is a sugarcane field, and this is the drone, and you can see that because image are very good, and then some sugarcane field or drone over the sugarcane field, and you can see that area of the sugarcane field. We have a different colors, different things. This is the area which we have seen. So you can see. So this is the 30th August 2000. This is the 9th July 2016. So just 1 year before, image was like this. Now the 30th August 2017 image is like this. And all the mosaicing we have done by our own. So whatever be the area, this is the sugarcane area. So we are much more interested, and this is the 30th August 2017. This is the sugarcane area. So what we are seeing here, we are seeing there are different color, and this is the one of the most important dangerous thing for the sugarcane, that is the weed. So you can see that. So this is the weed. So drone image, weed affected sugarcane. So this is the not affected area. So this is very important, because you cannot enter inside the sugarcane area. You cannot see what is happening in a very small area. So image looks very big, but once you are saying that this is a very small portion, only 0.23 square kilometer total area is there, in which there is a 1/5 or 1/6 area is sugarcane. So this is the weed affected, and then you can see that how it is changing. 12th August, the small area, then the 30th August, very big area, it is doing this. And then 7 September 2017, a patch created by destroying sugarcane for spraying weed control herbicide. So because that time we have mentioned that this is the patch. So once the tractor is going on and spraying all these things, a lot of damage in the crop is also there. So we should have some better, where early detection, early prediction can be done. So you can see that while tractor was going, so how much sugarcane was affected. You can see that this is actual weed. So this is the actual weed, and this is a very dangerous for the sugarcane crop. So so you can see that this is a completely covered the weed. So aerial view of weed covering sugarcane. So, and we have developed some technique while how to detect once it is started or something like that. Now, another very important aspect for sugarcane, if you'll see this image, I will take 5 to 7 minutes more because discussing online is the toughest job. So only you are talking. I don't know how many are listening or whatever with the thing, but so you can see that this portion is this one, and this portion is this one. The crop density in both places is very different. So how to understand that? Okay, only this portion of the field requires only this portion of the field requires some extra attention. So there is no need to irrigate the whole field, or there is no need to give some fertilizer or something like for the whole field. So therefore, we have developed such technique how to monitor it effectively. And then, as I have mentioned, that fusion, here we have fused the data of the drone because our aim is how we can get that type of accuracy with some satellite data. Here we have used the Landsat data, which has a resolution of the 10 meter, and then temporal resolution is approximately 12 to 14 days. And then you can see that this is the Landsat A data, and this is the true color, this is the false color. So, but because resolution is poor, because resolution is poor, so you can see that the same area is looking very blurred, and we are not able to see anything. Now our duty and our responsibility is that how we can get the same information as drone in this satellite image. So we have done the cloud masking, segmentation, and then we have developed the adaptive threshold selection and classified the image in a sparse and dense vegetation. So cloud masking, the for satellite is one of the most important tasks. So we have done the cloud mask, we have done the masking the cloud. Then segmentation, we have masked because in image a lot of portions are there, so we have masked you can see that we have masked we are developing the masking. So this is this area, zoom one is this one, and this is this area, zoom one is this one. So grid is 5 by 5, 30 meter by 30 meter. You can imagine how small area is. And then we are trying to detect this area using the reference data as a drone with the satellite. So we have just sugarcane area mask because we are not interested in the other area because making algorithm and stuff. So, and then band selection, separability index, we have developed the different bands, how they are working for, how they are giving the different data, different observations for these two type of fields. This is intra-field for this portion and for this portion. Because why we have taken 30 meter? Because the resolution of Landsat is the 30. Then we have developed our own algorithm. I'm not going to detail of the algorithm, how we have developed the adaptive algorithm. We have tested in many places and it is working very nicely. So you can see that once we have the Landsat image, and once we have classified it, it is a dense image, it is a sparse, and black is the node. So you can see that where we got the sparse, this portion is a very sparse. So we got this portion is a dense. You can see the dense and no vegetation. This portion is no vegetation. And you can see that area. That is the beauty for this fusion algorithm. Area computed by Landsat image and area computed by drone. 0.03 means sparse sugarcane, dense sugarcane, total sugarcane. So quite matching, quite good results are there. So we have tested in several places, and we saw that results. The developed algorithm has a very good potential to work for the precision agriculture, means intra-class classification, either it is a weed or it is some sparse or whatever. So sorry. So deliverables, drone system with multi-sensor customized integration for target detection, and it has a very great potential. And it depends upon us how effectively, how cleverly we are going to use it. Thanks for patience and a lot of rewards and this is going on. So if any question, I will be happy to. I think that in 1 hour I have approximately 1 hour completed.
Thank you so much, Professor Dharmendra Singh, for such an enlightening talk on the smart drones. And I'm sure there are going to be a lot of questions from the audience. So the session is open for questions.
Hi, I have a question.
Yeah.
Sir, how does one measure the dimensions or how long or the length from an image from when the drone is shooting pictures from different heights?
Yes. So that is a GSD. I have shown when the ground sampling distance is there. So at what height drone is flying, so we can measure the GSD. And I have shown you the area is total GSD multiplied by number of pixels.
Okay.
So you can calculate by that. Because camera, you are knowing that it is a 10 megapixel or 20 megapixel, how much in this one resolution is there. So total number of pixels you can calculate, and then GSD you can calculate. I have shown you in somewhere the GSD calculation. Ground sampling distance is important.
Yes.
Yeah, if you remember, I have shown somewhere the GSD. I think this is the. So by this you can measure the area and length of it.
Okay.
Yes. Yes. Any other question?
Any questions from YouTube?
Yes. I want to ask Professor one question.
Yeah.
I see whatever now you're showing, you must have used some drones.
Yeah,
Whether those drones were developed by IIT Roorkee or
No. It is we have a little bit modified the gimbal.
Okay.
According to our use, and it is a purchased one. And because we are now in the process to developing the drone. Means there are two things: manufacturing the drone or assembling the drone.
Okay.
So assembling, the maximum people are doing the assembly. And now we are in process to start making some propeller or something like that. So we are trying to manufacture, not the assembly or something like that. But till now it is a purchased one. Until now we have the capability to provide the assembled drone.
Okay. Now, second thing, what are the activities of your startup Dirghadi?
You can see the web page. I have a lot of products there. Agriculture related, software related, ground penetrating radar, through all imaging radar. In radar technology, a lot of products are there, and a lot of software ICT based solutions are there. So till before this pandemic, 2020 March, company was running quite okay. Means it was just I have started in 2017 only. June 2017. So, but after the pandemic, little bit tough to all, because maximum products are there. You have to go for the demo. You have to go for all other things. So, little bit difficult. Since last 1 year, facing a lot of problems on that.
Okay.
Yeah. So you can see that a lot of videos, a lot of things are there, which we have developed our own. I think from there, Dirghadi.com is the site.
And how much a drone cost, roughly, whatever drone you have used for this railway tracking?
Means cost of the drone now we reduced a lot. So if we have now in India, a lot of people, because
it is in lakhs or crores?
No, not crores. No,
lakhs.
Not crores. Lakhs only. Means it depends upon, the cost of the drone depends upon three things. First, the flight time duration. Flight time duration means 25, 35, 40 minutes, 50 minutes. And then the payload, how much payload it can take. And third one is the accuracy, how accurate it is going to be. So it is something like 4 or 5 lakh drones.
Okay. Thank you. Thank you very much.
Sir, I have a question.
Yeah.
So for something like real-time analysis using drone, and so that it actually identifies the fault in real time or whatever, the target prediction, and then communicating it back to the base. So what kind of infrastructure is required? And
Means now trans receivers are there, and very soon we are developing this also for real time. So now we have got success. So very soon it will be in real time. So once the drone will be flying, automatically you will be seeing all the things in your laptop or palm top or whatever.
okay. And will that require something kind FPGA analysis?
Doesn't matter. We are doing on the laptop only. Now FPGA, a lot of good processors are in the laptop, and that your whatever with the computing devices, smart computing devices are there. A lot of things are there. So no need to go for the FPGA.
Okay.
Yes. Any other question?
Anyone from YouTube? Amritanshu, can you check up there?
Okay, there is one question from YouTube from Mr. Mahadev Lokhande. What is the minimum size weight of the drone developed? Is there any constraint on the minimum weight of the drone, including sensor, etc., from the point of view of air velocity and fluctuations?
But currently, a lot of people are developing, claiming the things. Means something like I have gone through the drone of the size of less than 1 feet, 30 centimeter. So, but payload is very less. Payload is something like less than 500 gram or 300 grams, whatever. So people are putting some camera, and it is some suicidal drone, go there and then take some images and that, whatever.
Okay.
Propeller is good one, so that time the velocity and all you have to take care.
Okay, sir, I have
But you know now, means all these things while reading, while seeing looks very good, but a lot of problem we have faced. One thing I used to say that, because all these things drone coordinates where it, because now it is the auto flight mode is there. So a lot of sometimes it happens, its connectivity to the GPS gone, and when it's gone, then drone used to fall down, and that with big damage with that. And so 2 times we faced that problem. Fortunately, it fall down in some agriculture area, so did not damage a lot, but damage. So that is also a big challenge. People are claiming a lot of things, but I have 2-3 drones. What the problem? I have seen that this is one of the very genuine problem.
But nowadays you can use Indian satellite systems like Navig, etc. They have come and they claim it is better than GPS.
Getting the Indian satellite data is I don't think that.
Not possible.
No, not possible. No, everything is possible in India, but because as I have mentioned, there are once I am talking the cost effective. So there are 3 factors. One is the time. The second one is the computational complexity, and third one is the actual price.
Okay.
So once you are very much busy for just obtaining the data, if you have spent a lot of energy for that, so then your heat will be gone. So whatever with the freely data available, just you have write a simple project and then you got the freely available data or all other things, access, then you start working. So time complexity, computational complexity, and the cost. So these 3 things are very important for me. So for developing the product, otherwise you will be here and there only busy with the maintaining or just doing that. Because I used to give a customized solution from scratch to the end point. So and very much independent. A lot of 80% things are our developed. Yes. Anything else?
No, I think there is no other question.
Okay, thank you very much.
Thank you very much for readily accepting my request for delivering
अरे
a
सर
talk
आपका
and sparing
मायका
your time.
आपका मायका है सर, आप जब भी
नहीं,
कहोगे
जरूर, जरूर।
मैं आप
With-
जब भी कहोगे, रात दिन में जब भी कहोगे, अगर मेरे पास मैसेज आ गया मैं दौड़ता हुआ चला आऊंगा।
हम जरूर साथ में मिलकर कुछ और
हाँ,
करेंगे
हाँ।
देश के लिए।
Yes.
Thank you.
Thank you very much. Thanks to all.
We again thank Professor Dharmendra Singh for joining us today, taking out his valuable time to enlighten us on the topic of smart drones. Thank you very much, sir.
Thank you very much. Okay, thanks.
For joining us. And with that, we move towards the valedictory session. Yes, concluding session of the 4-day webinar series. I would like to request Mathur sir to say a few words.
I think we have invited 3-4 more people for this session, and I requested Amritanshu to coordinate this activity in case he is there. We have invited Mr. Vikram Desai. He is ex-director of DECU, ISO, Development and Communication Unit, Ahmedabad. And we have also invited Mr. D. Subramaniam, ex-deputy director of SAC Ahmedabad, and Mr. B.K. Jain, ex-head of division SAC, and to participate in this concluding session. I think if all of have joined, then we can continue. Yeah. Let us see. Is Mr. Vikram Desai available?
Sir, Vikram sir has joined.
Yes.
Our honorable
Desai sir has joined. Subramaniam sir is, I think, still not joined.
Okay. And there is no WhatsApp message also from him. He may have joined. And Mr. I think VK Jain also has joined.
Yes, sir. Jain sir is also here, and Ashish sir has also joined, sir.
Okay. Ashish also has joined. Okay, let me continue. Then we will take opinion of all other members. We had a 4 days program where we organized 12 lectures on the National Technology Day. And we tried to have all the topics related with advanced technology, just to show the path to our young engineers of the country, young students, research scholars, and faculty members, what are the new fields and where they can work together. In fact, so all the talks were very good. All the speakers, they accepted our invitation, agreed, and nicely delivered their talks, and number of clues they have given to our young engineers to work in those particular field. And there were participants who registered with us. There are around 345 or so, and they are from class 7th onwards to up to PhD level. And a few are the faculty members from various engineering institutions and IITs. So range was quite big, but response on YouTube, which I saw, was less. I don't know what is the reason. After resting, also many people have not joined. So hopefully this session, all the session must have been useful to these students. After we'll take opinion of these students, those who are right now attending this. And I request Chintamani also that we'll make this feedback form. And as we did last time, we'll send to all the participants through that Google link,
okay,
so that they can send their opinion about that. Thank you.
Thank you, sir. If Professor VK Jain is there, can I request Professor VK Jain to share his thoughts?
Good evening, everybody. Mr. Mathur, Mr. Chintamani Pai, Mr. Amritanshu, and other prominent speakers. I think Vikram Desai is also there, our ex-deputy director, as a director, DECU. So it's a wonderful event. It's a national events of Technology Day. So it gives a lot of inputs to the students, participants, they are familiar about the new technology and their uses. So if this knowledge is shared with among other colleagues, I think India will become fully Atmanirbhar in all these technologies, and we will come up and will solve many solutions. Like just now we have listened, Mr. This thing, airborne taxis and drone applications. They are very useful subjects, and it is for technical growth of the country as well as that solving our many key issues. This technology will definitely help, and all will be benefited. And these students and the research scholars, those who are here, they can do develop many more applications. They can develop use the hardwares, etc. So a lot of scope is there with this new technology, like 3D printing. We have detailed presentation about 3D printing, composite material, etc. So these all topics are very latest, related to space sector, defense sector, and also right now that this thing COVID pandemic situation, the drones and airborne taxis are very much useful. This patient can be lifted. In fact, my entire family is affected by this COVID, and all 6 persons are down. But still, in such pandemic situation, these things are very much useful, and people should use it. They should spread the awareness, knowledge, and I'm very happy to know that students from like 7th onwards up to PhD scholars are there. So that imagination of that young student, brilliant students are all will certainly percolate in coming years, and this will develop a healthy country with the advanced nationals. This is at least such type of seminars are really building our contributing our India nation towards self-reliance. So thank you very much.
Thank you very much, sir. I now request Professor Vikram Desai to share his thoughts.
Mr. Mathur, Mr. V.K. Jain, all speakers and participants, good evening to everybody. मैं आप सबका इस कंक्लूडिंग सेशन में स्वागत करता हूं। ये जो 4 दिन का आपने जो एक सेमिनार 11 से 14 मई 2021 में जो आपने ऑर्गेनाइज किया, एडवांस टेक्नोलॉजी एंड एप्लीकेशन इंजीनियरिंग, ये बहुत फैंटास्टिक एक एफर्ट आपकी तरफ से रहा। मैंने बीच बीच में प्रोग्राम्स देखे, और मैं जानता हूं कि जो लेटेस्ट टेक्नोलॉजी जैसे कि 3D प्रिंटिंग, इन्फ्लेटेबल स्ट्रक्चर, स्मार्ट मटेरियल, एयर टैक्सी, फ्लाइंग टैक्सी, स्मार्ट ड्रोन एप्लीकेशंस, रोबोटिक्स जैसे कॉम्प्लिकेटेड एंड लेटेस्ट सब्जेक्ट को आपने जिस सहजता से, जिस सिंप्लिसिटी से इसको एक्सप्लेन किया गया, जिससे कि जो 7th क्लास के स्टूडेंट से लेके PhD तक के स्टूडेंट्स, रिसर्च स्कॉलर्स को भी ये इजीली समझ में आए। और मैं ये भी जानता हूं कि ये जो प्रेजेंटेशंस और जो लेक्चर्स दिए गए, उसकी क्वालिटी वाज एक्सेलेंट। दिस मच आल्सो आई कैन से। आई एम वेरी हैप्पी टू लिसन सम ऑफ देम। ये भी मैं जानता हूं कि और ये मैं चाहता हूं कि इन जिस लेक्चर्स को सुनने के बाद स्टूडेंट्स के और पार्टिसिपेंट्स के टेक्निकल नॉलेज का अपग्रेडेशन होगा, और उनके भविष्य में जरूर से उनके जो प्रोफेशन में, भविष्य के प्रोफेशन में इसका यूज वो कर पाएंगे, और अपने लिए, देश के लिए और पूरे विश्व के लिए ये बहुत बड़ा सहयोग होगा। इन शब्दों के साथ मैं आप लोगों के उज्जवल भविष्य की आशा करता हूं। जय हिंद।
Thank you very much, sir, for your thoughts. May I request Dr. Pradeep Solanki to share his thoughts?
थैंक यू वेरी मच। ये 11 से 14 तक चलने वाला जो सेशन था, मेरे लिए तो एक नया अनुभव था और बहुत ही इंफॉर्मेटिव था। आशा करता हूँ कि नई पीढ़ी के लिए बहुत काम आएगा। मैं आदरणीय माथुर सर और जितने भी जो पार्टिसिपेंट्स स्पेशलिस्ट जुड़े थे उन सबको नमन करता हूँ कि उन्होंने काफी अच्छी इंफॉर्मेटिव नॉलेज दी और मुझे व्यक्तिगत बहुत लाभ हुआ है। आशा करता हूँ कि सभी को लाभ पहुंचेगा। थैंक यू सर।
May I request Ashish Soni sir to share his thoughts?
Unmute kariye Ashish.
Yeah, thank you very much. Basically, we were involved since last 1.5 months with Mathur sir for this upcoming program. Now it is not upcoming. We have on the concluding session today itself. And really, it's a fantastic journey of 4 days. And I really congratulate all the speakers, all the chief guests, and all the supporters and this team for a wonderful sessions, 12 wonderful sessions, which really enhance the knowledge of not only the students, but along with all the industrialists and research organization also. And looking forward to next event for again, and would be like to be a part of this. Thank you very much.
Thank you very much, Ashish sir. Is there anyone among Zoom participants who would like to share their thoughts and how they have found this 4 days webinar series?
Hello.
Hello. Yes.
Sir, thank you, Mathur sir, for arranging such a wonderful session. Actually, on the very first day, I was not aware about what are the different topics are going to cover in this session. But when I attend the very first session, then I come to know that how wonderful this webinar series was going to be happen. So I attend all the lectures very sincerely, and I come to understand the different recent techniques that are going to happening in the technology, the research related to some space, additive manufacturing, robotics. So it was a very great to attend this session, and definitely the technology, I can say that not 100% we can understood, but whatever the things we are come to know, we definitely search related to that topics and upgrade our knowledge. And in the future, if such a sessions we are going to attend or such a sessions are arranging, then kindly inform us. Already we have registered, so you have our mail IDs. So kindly inform us whenever such wonderful sessions are going to arrange. Thank you so much, sir.
Yeah, I'd like to inform all the participants, those who are here, they can click our YouTube channel icon and subscribe that. And we definitely has got email IDs of all the participants. We would be sending the details to them. And I am also thankful to all the supporters and sponsors that they have supported wholeheartedly to us. And we try to keep the fee as minimum as possible. Up to UG level, actually there was no fee. So we are not charged from ITI, diploma and undergraduate students any fee for these 12 lectures. Only those who are doing post-graduation or they are in the job, we charge a very nominal fee, and that too for a few of our minimum expenditure. So we will try in future also that we give this education or transfer the knowledge at zero cost. Thank you.
Amrita Anshuji, would you like to share anything?
So, first of all, thanks, dear organizers, ISI, for considering me as a part of the organizing, this entire organizing team. Special thanks to the Indian Space Industries Exhibitors Board, which actually planned the session. And the meticulous planning it simply is reflected by the fact that how so variety of the entire diaspora of advanced technologies has been covered in these 11 special sessions that we had. So there are, what you can say, fabulous, fantastic, and fantabulous are the only three words which I have. And still, the opening remarks by Dr. P.V. Venkatakrishnan, who who wanted India to be propelled onto the path of investigative approach by diving deep into the capacity building. And I am pretty much sure that onto the last 4 days under the aegis of ISIE, I am pretty much sure of the fact that yes, the investigative spirit which our honorable chief guest of the first day wanted to develop into the young ignited minds of India has been served. And into my concluding remarks, I just would like to wish ISI all the very best and for the future such programs, and would like to end up on the note that the three-dimensional world that our eyes perceive only in two dimensions. In fact, the first dimension is the dimension of education, and that stands satisfied in the last 4 days. Thanks, ISI. Thanks, Mathur sir.
Thank you, Amritanshu ji. Is Mathur sir there? Yeah.
And before Mathur sir begins, I just would like to give a special word of thanks to the young, very wonderful and dynamic hosting done by the Space Geeks Mumbai under the leadership of Sri Chintamani Pai sir and our Hariom Tejas Iyer sir. Had you not been there, the program would have been rendered incomplete without your competence over the technological as well as the scientific aspects combined together in a very, very great equitable ratio. So thanks Chintamani sir and thanks Tejas sir. Over to Mathur sir.
Yeah, I would like to thank at last Chintamani specifically. He, since last 1.5 months, he is working with me for planning this program. And all the brochures, posters he has designed. Till late evening up to 1 o'clock, 1:30, he works and send me the poster for comments. When I get up early morning, I see that Chintamani has sent so many WhatsApp messages, I had to reply that. And I'm also thankful to Space Society of Mechanical Engineers who have also joined us and supporting this particular event. Of course, Ashish is there. He is the Secretary of Space Society of Mechanical Engineers who has supported us. Jain Saab support also I have received. But this time Jain Saab could not attend most of the time because of his problem, this COVID problem. And in spite of that, he supported me. He was the coordinator for this particular program, all correspondence and WhatsApp and email he did. So without the support of all these people, now it was not possible for me to organize such event. Lastly, recently I got another diamond from Uttar Pradesh. I call it Amritanshu. Now, who has also given support everywhere, whether it is preparing a press report in Hindi, English, or organizing anything or conducting any session. So he has got a good command over Hindi as well as on English. A very perfect man. And thank you very much, Amritanshu. And I hope I will get support in future also from all of you. And I would also like to thank you, Mr. Vikram Desai, who is also an honorary advisor of Indian Space Industry Exhibitor. So we have got 6 advisors. He is one of them, and time to time he gives all his suggestions and opinion to organize the programs. Good comments. So thank you, Vikram, for all this, and hope in future also I will be getting support from all of you in conducting such programs. Thank you.
Thank you very much, sir, for always being there and inspiring us to be a part of such events. We are very much fortunate to receive the guidance from experts like you. And so as we move towards the end of this session, sir, as I said, can I now share the video? Because all of us have a passion, and that passion has brought us together to conduct this event. And we know that unless and until there is a passion, these kind of events, whether you are part of the organizing committee or you are a session speaker, then only you are able to resonate, and these events become successful. So I would like to end the webinar series by sharing an inspiring video, and all of you know this guy, and he's trying.
Should we have a former vote of thanks before that?
Yeah.
Then you can conclude with a
Yes,
video
yes,
if
sir.
I
Yes, sir.
interrupt
No
you.
problem.
Please. Because it's a duty and we have our schedule that for formal vote of thanks for all 4 days. Of course, Mathur sir has done with everybody's name, but still some names are suppose missing. Let me conclude this by vote of thanks that we have reached to the destination. And I mean at the 4th day webinar on advanced technologies by celebration of National Technology Day from 11th May to 14th May. And it's my privilege to give away the vote of thanks for this event, which we have completed with a great success. The seminar was really very, very helpful for not only the students, academic institutions, but also for research organization and for industrialists also. And for this, we are really thankful and for great efforts from, first of all, very much thankful to Sri Ashi Mathur, MD ISI, and all office bearers of ISI for their continuous involvement for this program. We are thankful to Dr. P.V. Venkat Krishnan, Director CBPO ISRO Headquarters, for accepting our invitation for chief guest and to grace our function. We also thankful to Sri Dinesh Kumar, Chairman, Institute of Engineers, Delhi State Center, for supporting this program, and thankful to Sri V.K. Jain, Chairman, Broadcast Engineering Society, Ahmedabad, and Sri Anand Pathak, President SSME, Ahmedabad, for their continuous support. Eminent speakers of all the sessions, without who share their knowledge to all of us. We are really thankful to all 12 eminent speakers for 4 different sessions who enlightened us thoroughly. I'm also thankful to distinguished panelists, Subramaniam sir, Sanjay Upadhyay. Mostly they were not present due to some reason, but Shri Vikram Desai sir, along with all Mathur sir, VK Jain, and all who are present right now on Zoom platform. We are thankful to our sponsors, supporters, namely Space Society for Mechanical Engineers, SSME Ahmedabad, Broadcast Engineering Society Ahmedabad, AI Robotics Bangalore, Space Geeks Mumbai, IIT Roorkee Alumni Association, and URO 77 Foundation. We are thankful to our media partner, Sunrise India Samachar, New Delhi. And how I can forget our audience, because वक्ता कितने भी अच्छे हो, बिना श्रोताओं के वे भी अधूरे हैं. So we are thankful to all our audience, students of Institute of Engineers and all members of various technical societies and all the audience across India and from everywhere who has joined through online platform of YouTube. Thank you, audience. And I would like to mention that the program will remain on YouTube, and once again you can see it, share it at any time to anyone to enhance your knowledge. And I request bell icon, subscribe ISI YouTube channel also. And I also request to fulfill the feedback form and send it to us. In the end, with this current scenario, I pray to God for your healthiness and happiness throughout your life. And definitely, yes, excuse me if I forgot any names, and also excuse us if you found any glitch in the program. If you like the program, share it to everyone, and for any inconvenience, do write to us. Definitely, we will implement shortly with in our next program, and shortly we will be with you with new program. So final goodbye. एंड अंत में अगेन 4 लाइनों के साथ जो है वो मैं आपको अलविदा कहना चाहूंगा कि सुप्रभात का उजाला सदा आपके साथ हो, हर दिन हर शुभ पल आपके लिए कुछ खास हो, दुआ हमेशा निकलती है दिल से आपके लिए, ढेरों खुशियों का खजाना आपके पास हो. Once again, stay home, stay safe, wishing you a happy and healthy life. Thank you. Over to Chintamani.
Thank you, sir. And with that, now I am sharing a video. I know all of you know this guy who has been doing something extraordinary in the field of space. And let us conclude this session with this video. And with his enthusiasm, he is actually spreading all over the world, and he has been really inspiring to all of us.
Most space organizations, government or commercial, have set their sights too low. They've really
Chintamani sir, we are not able to see your screen.
And Falcon
Just
Heavy
wait.
is the first time that there's something that's arguably even in the super heavy class or somewhere between heavy and super heavy. You know, 5 million pounds of thrust is really crazy amount of power.
Audio is coming.
There's any other rocket. Okay.
Hotels in the area are completely sold out. Parking lots are packed.
It's like the first time something exciting has happened in rocket launch in a very long time. Falcon Heavy is configured for flight.
T-minus 15, stand by for terminal count.
SpaceX Falcon Heavy, go for launch.
10, 9,
All systems go.
8,
3 this ignition.
6, 5, 4, 3, 2, 1.
So I feel space, he has brought the space with an enthusiasm. And only this kind of enthusiasm will take the youth of this country ahead.
Side boosters.
Oh, wow.
And that landing burn has started.
Gotcha, I see it. Yeah, I got him. They're there. Oh my God. You've got to be kidding me. What?
So there we are. Thank you all for joining. And this video really spreads the enthusiasm about space, and the youth of this country, we need that kind of enthusiasm. So thank you again for joining us for this webinar, and it's time to say goodbye.
Thank you all.
Thank you.
Bye.